Well, good day to you, good evening, good morning, whenever you're watching this. My name is Filagahle Manana, and welcome to MV Tutors. Okay, so we are doing mathematics paper 1, the November 2021 paper 1. Now, this is the national exam that you just wrote, so we'll just be doing a short memo on it. Well, nothing short about it, it's the full memo. We'll just be trying to explain it in a more digestible way. Now let me just say that the memo from the department that actually set this test is not out yet. This memo is the one that we are developing ourselves, but mathematics is a universal language. 2 plus 2 is always 4, so we are pretty confident of our answers. Okay, so let's get right into it. Now, the first question, if I can just zoom in there, as you can see, that's the first question is to solve for x, and we are given, let's do a black pen, we are given x squared minus 2x minus 24 is equals to 0. Whenever it's equals to 0, you know you have to solve for x, but if it's not equals to 0, then it's just factorizing. Okay, so here we're solving for x. We're just gonna simply open two brackets and make it equals to 0, and then now what we want to do is get a multiples of 24. So I have 24 and 1, but now what I should be able to do is take these multiples of 24 and create minus 2 when I add them up. So 24 and 1 doesn't help me. Let's try the next multiple, which is 2 and 12. Will I get minus 2 from these if I add them or subtract them? No. Let's try the next one, which is 4 and 6. Okay, 4 and 6, I can work with them. Now, how can I get a negative 2? Well, basically, I have to say plus 4 minus 6. Okay, and then that will give me a minus 2. Okay, so that satisfies it. So x, I put it exactly as it is, x minus 6. And then when it comes to solving for x, you know you have to take the opposite of this, right? Because remember, what's actually happening here is that it's equals to 0. If you're to solve for that, equate it to 0, x is always can be negative 4, the opposite sign. So that's why we always take the opposite sign. Okay, and now for this one, I'm just gonna say or and. I'm not quite sure what's the difference between or and and. It's or, but you know, just use and or. It's up to you really, unless your teacher specifies that you should use or and, you know, just either of them will work. It depends on the question at the end of the day. Okay, so we are cool with that. This was 1.1. Now let's go check out 1.2. It's right over there. And then what I want to do as well is just solve it over here. Now I like to use different color pens, so let's go for red this time, and it's gonna be 2 x squared minus 3x minus 3 is equals to 0. Okay, so here, right over here, what I like to do is that, you know, for this question, what I want to do is to use the quadratic equation, where that's a that's B, and that's C. I always write these variables on top because in the heat of the moment of the examination, you know, it's easy to make a mistake. So I want to eliminate the guesswork out of it, and I do that by actually naming the variables, so that when I get to this stage now, when it says minus B, I know where to go for B. I can see B is actually a -3. Okay, and that's going to be plus or minus B squared. It's -3 again, but any number squared, really, it doesn't matter whether it's negative or positive when it comes to squaring. Okay, so A, take out the guesswork, it's 2, and then C, take out the guesswork, it's -3, like that. And all of this is under a square root, and underline that, and it's over 2 times what's A? A is 2. Okay, so what we need to do now is get a calculator. Let me get my calculator. There it is. So this is the calculator you should be using in your matric. It's just a standard scientific calculator. So here I'm just gonna put a +3, because if I multiply a negative and a negative, I get a positive, and I'm gonna add that, put the square root sign, and then we're gonna go 3 squared minus 4, 4 times 2 times a -3 times a -3. Okay, and all of that is gonna be over 2 times 2. Okay, let's change it to decimal. 2.18 is equals to 2.186. Okay, so that's my 1x, or x is gonna be, now we need to change the negative into a positive. I mean the positive into a negative, because we put plus here. So let's subtract this time, and then we'll get 0, negative 0.686. I just did 3 decimals. I'm not sure whether did they specify how many decimals. Oh, they did. Correct, to 2 decimals right over there. So since they specified, then we should give it in 2 decimals. So this will be 2.1. Okay, 6 is bigger than 5, so I change a 18 to a 19, or x is equals to -0. Okay, 6 is bigger, so I change it 68 to 69. Okay, those are my final answers right there. Okay, right there. Cool. All right, so that's that. Let's go check the next answer. I mean the next question. Let's go down the page also here. All right, let's change the color. Let's go for blue. Now we have x squared plus 5x is less than -4. Okay, so what I'll do is just bring the -4 this side, so that I have, this is what we call an inequality, right? Okay, so let's just factorize this once again. Okay, so in factorizing this, I want multiples of 4. So the first one is always 4 and 1. It's always 1 and 4. How can I add these up to get a +5? Well, both of them have to be positive. So it's +4 plus 1. So here I'll put x plus 4. I put them exactly as they are, plus 1. Okay, So remember what this is, what this really is. This is really y, okay, because y is equals to this thing. So when we say when we say this thing, we're saying y is less than 0. Okay, so we're looking for y values. We're looking for the y values that are negative, that are less than 0. So what we do then is that we'll draw just a rough sketch. Okay, just a rough sketch of these values. We need x is -4 and -1. So we have -1 there and we have -4 there. So now we always approaching from the left, right? Always approach the graph from the left going right, and we know positive values are this side, negative values of y are this side. So when we approach from here, we see that for all the x values we are on the positive side on the graph, because we're approaching on the left, we hit the graph, we're on the positive until we reach -4. So what we're going to do then for our answer, we're going to say x is an element, square bracket, because there's an equal sign there, from -4, that's where we start being negative, and then all the way to -1, square bracket as well, and then after -1 we're back on the positive side. So this is our final answer right there. Okay, it's good. Moving right along, the next question. Very interesting. Okay, let's change our color once again. Let's go for green this time. So we have a square root of x plus 28, and all of this is equals to 2 minus x. Cool. So as you know, get rid of a square root by squaring. So what we do on one side, we do to the other, and then we'll have x plus 28 here is equals to I like to actually put 2 of these. Okay, so let me just put them together. So it's 2 minus x and 2 minus x. Okay, so I do this so that I can do that. 2 times 2, draw those lines on top, they help under the exam stress. So 2 times 2 is 4. Next one is 2 times minus x, that's minus 2x. And then the next one is minus x times 2, which is still minus 2x. And then the next one is minus x times minus x, which is positive x squared. Okay, so what we want to do now is just bring these to on the other side, so that we'll have 0 is equals to I'll start with x squared, and then minus 2 is minus 4. Minus 4, if I bring this other this x to the other side, it becomes a minus x as well, so then I'll have minus 5x. And then in terms of numbers, I have 4 this side, and then I have 28. So what's 4 minus 28? It's actually 24. Okay, so once I'm here, I need multiples of 24 that can give me 5. But you know what? I'm going to use the quadratic formula because I don't want to think too much. So it's minus b. So let me just put my variables there. It's a, b, c. Okay, and then what I have here is minus b, which is, let me just put it exactly as it is, minus 5. And it's going to be plus or minus square root of b squared, which is 5 squared, minus 4 times a is 1, times c, which is minus 24. Cool. All of this under a square root divided by 2 times a is just 1. Okay, let's bring back our calculator. There we go. Start with the fraction. We got 5 there. Start with the plus, square root sign, 5 squared minus 4 times 1 times negative 24. Okay, and then I come downstairs, I put a 2 there. That's equals to 8. So my first x is equals to 8, or x, what do you think it's gonna be? 24 divided by 8, what is that? 8, 16, 24, that's 3. So we're probably gonna get a 3 here. And will it be negative or positive? It should be negative here on the answer, but let's just do on the calculator so that we'll be sure. Under exam stress, it might not be advisable to do what I just did and just put it, but let the calculator speak for you. But in any case, our answers are the same. There we go. So x is equals to minus 3, or x is equals to 8. Okay, thank you so much, calculator. Moving right along, what's the next question? Let's zoom out a little bit. Oh, solve simultaneously for x and y, and here are the equations over here. All right, let's do that. Okay, so I got a new color here. It's like a rainbow color. Let's see what it looks like. Let's see if we can use it. 2 looks a bit yellow. Y is equals to 3 plus x. Let me just, I don't like this color. You know what? I'm not going to use it. Let's start again. Let's go back to black. So we've got 2y plus 3. What did I just do? 2y is equals to 3. So 2y is equals to 3 plus x. I just want to rearrange this so that it's x is equals to 2y minus 3. Okay, so this is gonna be my equation number 1. Okay, so my equation number 2 then is gonna be 2xy plus 7 is equals to x squared plus 4y squared. Okay, that's gonna be equation number 2. What I want to do now is take equation number 1, okay, and put it into equation number 2. Is that okay? Can we do that? Let's do it. I need more space. So what's my equation number 1? So where there's an x, I'm going to substitute 2y minus 3 in equation 2. So let's start with equation 2. It's 2. Now I have an x, so where I have an x, I'll put 2y minus 3, right? And then I have a plus 7 there, and put that is equals to, I got an x here, okay, so, and it's squared, and x is 2y minus 3. And I actually want to put 2 of them for just ease of calculation, because it's squared, it means it's 2 of them, plus 4y squared. Cool. Now let's multiply in. So 2 times 2y, that's gonna be 4y. 2 times minus 3, that's minus 6. I got a plus 7, that's equals to 2 times 2y. 2y times 2y, that's 4y squared. 2y times -3, that's -6y, and then -3 times 2y, that's another -6y, and then -3 times -3, that's a +9, and then plus 4y squared. Let's continue on that trajectory. So now what we want to do is combine the y squareds. So I'm going to just put everything on one side. That's 0 is equals to 4y squared plus 4y squared really is just 8y squared. And then let's talk about the y's now. -6 minus 6, that's -12. If I bring the -4 to this +4, it becomes -4. So -12 minus 4, so that's like 12 plus 4, which is 16. So it's -16y. Okay, and then let's talk numbers now. -6 plus 1 plus 7 is +1. So if I bring it this side, it becomes negative, and then this is 9 minus 1, which is a +8. Cool. And then what do I have now? I have this equation. Oh gosh, I'm just gonna do a quadratic, I don't want to waste my time. So it's minus b is -16 plus or minus square root of b squared. What's b again? It's 16 squared minus 4 times a is 8, and then c is another 8. Put that under a square root, divided by 2 times a is 8. All right, we need your services calculator. Okay, so there we go. So it's +16. We'll start with the plus, square root sign, 16 squared minus 4 times 8 times 8 divided by 2 times 8. Okay, there we go. Wow, our answer is 1. All right, so that's 1x, or x is equals to, what's the other one? We have to go change the positive over there and make it a negative. So I'm going to delete this, put it as a -1. I must have made a mistake somewhere, because this is not what I practiced. Okay, let's just recheck our y, our values once again. So that's 8 minus 16. I said 6 plus 6 minus 4, and then I said -6 plus 1. Let me see, something's missing. You know what's missing? If you look at our equation over here, there's a y. It's supposed to be 2xy, so it's 2x, and then there should be a y over here, which then means, wow, this changes everything. Okay, so here's what I'll do. Normally I would kinda just what do you call this? I would delete and start again, but I don't want to be so drastic, because I want you to learn what to do when you make a mistake, right? You should be able to rub and start again. Okay, should be able to cancel and then start again. You know, reevaluate your mistake. It's good to make mistakes in mathematics, because when you've made a mistake, then you know to reevaluate what you did wrong and start again to get your answer. It's part of learning. So here I should have 2 times 2, which is 4, right? Get my pen. Which is 4, and then I have a y here, and it's a y times another y. So there's a y here that we should actually multiply with as well, consider. So it's y times y, which is y squared. There we go. And then the next one, it's 2 times -3, which is 2 times -3 is -6, and then I got a y as well to multiply with here, so it's -6y, and then this plus 7 is outside. Okay, we're all good now. We can start adding them up. So it's 0 is equals to 4y squared plus 4y squared is 8y squared, and then I want to when we bring this one to the other side, it becomes minus. So it's 8 minus 4, which is 8 minus 4 is 4. So it's 4y squared. That's my final one. Minus 12. If I bring minus 12, if I bring this minus 6 to the other side, it becomes a positive 6. So minus 12 plus 6 is actually 6. It's minus 6y. Okay, and then with numbers, now it's 9 minus 7, which is plus 2. See what a big difference it makes. Okay, that is exactly why you should learn to change your answers and reevaluate and start again. Okay, so now I can use my quadratic equation again. So it's minus b. So minus b, let me just put my variables a, b, c. So minus b is minus 6 plus or minus square root of b squared. B is 6 squared minus 4 times a is 4, and c is 2 divided by 2 times a is 4. Okay, now let's put this in the calculator. Start again. Okay, so minus 6, that's just a positive 6. Start with the plus, square root of 6 squared minus 4 times a is 4 times 2. Let's come downstairs. It's 2 times 4. Okay, 1. Alright, we still get 1. That's okay. Or step back, eraser. We don't need you anymore. Or x is equals to, let's go change that. Plus, delete, put negative, and then go equals. X is a half. There we go. Okay, so remember this is simultaneous equation, so we are not done. We still have to put it in the original. We still have to solve for y. Okay, so you know, we made another mistake. We were actually solving for x here, not y. I mean, you were actually solving for y. At least this time the mistake is actually bearable. It's not as bad. We just have to delete x and then put y, because you see this equation is made of y, so this should be y. And based on equation number 1, x then is equals to 2y minus 3. So if y is 1, then x is going to be 2 times 1 minus 3, which is 2 minus 1 minus 3 is minus 1. Okay, that's my x if my y is 1. Let's do the same this side. It should be x then will be equals to 2 times a half minus 3. 2 times a half is like saying 2 times a half is a 1, so it's 1 minus 3, which is minus 2. So x is minus 2 if y is a half. Wow, this was quite a mouthful of a question. But we soldiered on and we got our answers. Okay, now we are on the last question here. Let me just zoom out so that we can read it. It's quite a long one. Anyway, it says the roots of an equation are x is equals to minus n plus. This is a quadratic equation. It's a quadratic equation, this, where m, n, and p are positive. It's very important. Real numbers, so positive real numbers. The numbers m, n, and p in that order form a geometric sequence. Okay. Prove that x is a non-real number. Okay, so we gotta prove something here. All right, let's take it step by step. Let's go for ready this time. So first of all, we know, let's start at the end and work our way backwards. So they're saying prove that x is a non-real number. Okay, a non-real number is when the discriminant, okay, is less than 0. That means the discriminant is negative, right? The discriminant is this side inside a square root, so n squared minus 4mp in this case. Okay, so we gotta prove that this thing is negative. That's what we gotta prove. Now let's go get some clues from the question. So they say the numbers m, n, and p in that order form a geometric sequence. Okay, and then what do we know about geometric sequences? It's that, okay, let's put this m, n, and p. Remember, the ratio for geometric sequence is such that term 2 divided by term 1 is equals to term 3 divided by term 2, right? I'm just gonna rearrange these, cross multiply, and n times n is n squared is equals to m times p. Okay, now we've got this. Okay, now we have to prove that this, remember what we have to do is prove that this thing is negative. How can we do that? Look at this. We have that n squared is equals to mp. So remember the equation that we do have is that we have n squared minus 4mp. That's what we have to prove is negative. So we'll take the n squared is equals to mp, and where we have n squared, we'll just substitute mp minus 4mp, and then we'll factorize, take out mp because it's common on both of them. So it's 1, we're left with 1 here. minus 4 this side. Okay, 1 minus 4 is minus 3, so minus 3 MP. Okay, so since we've proved that this thing is negative, then we've proved that it's non-real. Okay, so we can conclude then and say since minus 3 MP is negative, therefore, look at this. What did they say? Therefore, X is a non-real. Prove that X is a non-real number. Non-real number. You know why? Because you can never have a square root of a negative number. That makes it non-real. Anyway, that's the end of question 1. I hope you understood. This took very long, but I needed to make sure that we do everything right and that I explain everything in a more digestible way. Thank you so much for listening, and remember, or just to let you know, I'm available to tutor you if there's something you did not understand. Just visit my website www.mvtutors.co.za. book a free consultation there, and remember, the consultation really is just for you and your parent or guardian to meet the both of you. Please involve your parent or guardian before you contact me, because they are the ones who are going to be paying for my services, and so they need to be informed when you need tutoring. Other than that, it's goodbye from me and all the best.
Hello everyone, and welcome to MV Tutors. I'm Solo, and I'll be looking at question 2 with you guys. So yeah, we're finally doing the memo. Thank you for your patience, and please don't forget to spread the word. There are those who have also written and are wondering if they did well or not, so please share this video with others, send them the link, like our videos, subscribe to our channel, you know the drill. Okay, let's get to it. Question 2, given the geometric series, please just excuse the cut out numbers there. We were in a hurry to get this paper. So yeah, the pics were taken. And yeah, thank you at Mlemisinkosi for providing us with the maths paper. So yeah, let's get to it again. So given the geometric series, x plus 90 plus 81, okay? So now we need to calculate the value of x. So I'm just gonna write down there, okay, 2.1. Okay, so we have the series there. It is x, and we have 90, and we have 81. Okay, so since it is a geometric series, we know that we're going to have a common ratio, right? Okay, so the common ratio between 90 and x is the same as the one between 80 and 90, hence it's common. Okay, so what is r here? What is the common ratio? We have there 81 over 90, all right, and we have r here as 90 over x. So if we were to calculate the value of x, okay, so we're simply gonna say 90 over x is equal to 81 over 90, because it is the common ratio. Okay, then I'm going to take x to the right, and I'm going to take 90. Actually, you know what? Let me just simplify this. 81 divided by 9 is 9, and 90 divided by 9 is 10. Okay, that's much better. I don't want to work with very huge numbers. Okay, so I'm going to take x to the right-hand side, and we're going to take 10 to the left-hand side. So I would have 900 this side, and I would have 9x. Okay, so this was simple enough. In this case, we have that x is 100. Okay, let me just shift the page up. Right, and then now for 3.2, no, 2.2, I'm already ahead. Okay, so for 2.2, show that the sum of the first n terms is equal to that which is given. Okay, so the sum equation for a geometric series, okay, so you have Rn minus 1, and at the bottom you have R minus 1. Okay, so we're just going to substitute what we know and then work it out until we get what is given. Okay, so we know that the first term is x, which we just solved to be 100. Okay, and then R, in this case, it would be 9 over 10, which is 0.9. Okay, so I have 0.9 here to the power n, okay, minus 1. All right, and then at the bottom I still have 0.9 minus 1. Okay, so now let me just shift the page a bit up. Okay, so now if I multiply this 100 in, okay, I actually have negative 100. I multiplied first with a negative 1, and then I'm going to add it there. So I have 100 and 0.9 to the power n. Oh, actually, no, you know what? I'm deviating from what we have been given. Okay, let's rather do it this way. Okay, so in our, okay, if I were to take the negative sign out, because I see here I should have 1 first. Okay, so if I were to swap these around, take out the negative, okay, I would have negative 100, right? And in there I would then have 1 minus 0.9 n. So okay, at least it's looking like we're getting somewhere. And in the bottom, if I have 0.9 minus 1, that will be negative 0.1. Okay, and if I take 100 and divide it by 0.1, it's going to give me 1,000. Okay, you can check on your calculators. Negative and a negative will turn into a positive. So now I don't have a denominator anymore. Everything is on one straight line, and we have exactly what we were asked for. Okay, great. So we have shown that, and we can move on. This is quite a short question. I hope that you guys actually did well in it. All right, and then they say hence or otherwise calculate the sum to infinity. Okay, so you know when we calculate a sum to infinity for a geometric series, the assumption is that the series is converging. By converging, it means that if you have a big number initially, that big number is going to go all the way until, you know, infinity is where it's actually, yeah, it reaches infinity at that point there where it's quite small, but it's converging to one value basically. Okay, so what is the formula? The formula for sum to infinity is a 1 minus r. Okay, and our first value again, it's x, which is 100, and 1 minus r, like we said, it's 9 over 10 or 0.9. So we have 0.1 there, and then our answer is 1,000. Okay, so yeah, that is us calculating the sum to infinity, and we're pretty much done with question 2.3. Okay. Actually, you know what, I'm looking at this hence. Okay, this hence should actually follow from 2.2. If I have a look at this answer over here, if I take in to infinity, do you realize I have 0.9? If I multiply, or rather if I take 0.9 and take it to the power of a very huge number, it's actually going to be close to 0. So if I have 1 minus 0, that's just 1, and 1 times 1,000 is 1,000. And I can show you here. If I were to take 0.9 and take it to the power 1 million. Okay, how many zeros do I have? 1, 2, 3, 1, 2, 3, 4, whatever. Let's just take it all the way. It's close to 0, so hence I didn't really have to use this equation, okay? But it's the safest thing to do. So there you go. Your answer is 1,000. Okay, thank you. We'll see you for question 3. Welcome back, everyone, and now we are looking at question 3. Okay, so yeah, let's get straight to it. Consider the quadratic number pattern, -145, -122, and -101. Okay, so let's just write those values down and then see. So 3.1 already, they're asking what the fourth term is. So now we need to have a look at actually the trend here. Okay, we know already it is a quadratic pattern. All right, so we know that we have a first difference. Okay, this will be T4. We have a first difference here, and if we take -122, so I'm definitely using the calculator because I'm not trying to be very smart in the exam lest I make silly mistakes. So yeah, -122 minus 145, that's pretty much 23. Okay, and then we get -101 minus -122, and that is 21. My light just fell, but the show goes on. Okay, and here we have T4 minus minus, which will become plus 101. Okay, and then we have the second difference. So 23 to get to 21, we had to subtract 2. Okay, yeah, so even there we'll have to subtract 2. Okay, so in any case then what would be this value? If I were to take 21 and subtract 2, my value there would be let me not erase it, let me just continue writing. So my value there will actually be 19. Okay, 21 subtract 2, you get 19. And then what exactly will be our terms? So if I take -101 and add 19 to it, the answer that I will get is -82. So that is actually T4. Okay, so I have -82. So that is our answer for 3.1. All right. Okay, let us move on to the other question. So 3.2, it says that show that the general term of this number pattern is Tn is equal to -n squared plus 26n minus 170. Okay, so basically I'm going to use the values here at the edges. Okay, so I discussed in depth in one of our videos for sequences and series. If you don't understand why I'll be doing this, but yeah, so we're gonna have 2a is equal to -2. Okay, so therefore we have a as -1. Then we're going to look at 3a plus b, which is equal to 23. All right, and we already know that a is -1, so we actually have -3 plus b is equal to 23. Now if I take -3 to the right hand side, I'm going to get 26. Okay, it'll be +3 plus 23. So it is 26. B is 26. And then finally, we have a plus b plus c is equal to -145. Okay, so a is -1, b is 26. Okay, so already I have 25 on the left hand side. Okay, it's equal to -145. So c is equal to -145 minus, not plus. So -1 plus 26 is positive 25, and if it goes to the right hand side, it will be negative 25. Okay, so what is -145? Again, we go straight to the calculator. You want to save time. I know you can do it. I can do it too, but we're saving time here and we are working accurately. So we have -170. Okay, so if I were to write then the term formula, I have negative n squared plus 26n minus 170. Okay, so this is my quadratic formula. If I were to sketch it, because of this negative here, I would have a sad face parabola. Okay, so yeah, that's just one way of finding these sequences in series better. Just imagine the graph that forms, or what would actually be plotted. So for an exponential graph, no, for a geometric series or sequence, you get an exponential graph. For an arithmetic series, you get a straight line graph. And for this quadratic series, you actually get, actually it's quadratic sequence, you actually get a parabola or a quadratic equation, formula, or graph rather. Okay, so yeah, this would be a sad face parabola. So moving forward, okay, so 3.3, it says between which two terms of the quadratic pattern will there be a difference of -121? Okay, if I have a look again at my pattern, this is 3.3. I am in a rush. I don't know where I'm rushing to. So if we have a look at our pattern here, okay, so let me just use a different pen. So I have term 1, so my quadratic pattern for term 1, quadratic, term 2, quadratic, term 3, and yes, quadratic, term 4. Okay, and the second line actually gives you an arithmetic series. So this will be my arithmetic series for term 1, arithmetic series, term 2, arithmetic, term 3. Okay, so if I'm looking for between which two terms of the quadratic pattern will there be a difference of -121, I'm basically looking for a term on my arithmetic series, okay, that will be lodged in between the two quadratic terms. Okay, so basically if I were to be looking for, let's say we're looking for the quadratic term 2, it'll be in between the quadratic term 2 and the quadratic term 3. Okay, so I hope you see the pattern here. So 2 will be in between 2 and 3. If I were to look at 3, that'll be in between T3 and T4. If I were to look at T1, that'll be in between T1 and T2. Okay, so basically, if I'm looking for the difference of -121, I need to go solve for n and see where that is, okay, in my arithmetic series. Okay, so let us do it. Let us solve it. Okay, I actually need I need my series. So my arithmetic series, I have Tn is equal to, can you put my mouse at the bottom? I look so weird. I need to shift it around with my skinny arms. Anyway, Tn is equal to A plus n minus 1 d. Okay, so I know A at this point in time, that is 23, and n minus 1, and my difference there, we've already seen it on the second differences there, it's actually -2. Okay, so now I can get my Tn formula. Okay, so I will have, I'm just going to say -2 times n. I have -2n, positive 2 plus 23. Okay, and then I have -2n plus 25. All right, so that is my Tn formula. All right, and I need to know then what the n value will be if I have negative 121. Okay, so negative 2n and positive 25. So therefore I can say negative 2n is equal to negative 121 minus 25. Okay, so if I use my calculator quickly, I have negative 121 minus 25, and that is negative 146. If I divide that by negative 2, I will get 73. Okay, so my n is 73. So now, if I have my arithmetic series or sequence, I have a look at it and I have term 73, it will be lodged in between 73 and 74. Okay, and if you want to check that, I mean, for those who want to go to the next question, please feel free. But for those who love checking, let's check it. Let's see. So if I have, for my quadratic pattern, if I have T73, that'll be actually negative 73 squared plus 26 times 73. Remember, when you're looking for the term n, you can't have a negative value. Okay, you can't say I came in at negative 4th place. It has to be a positive whole number. All right, so if I plug that into the calculator, I will get, so negative 73 squared plus 26 times 73 minus 170. Okay, I get negative 3,601. Okay, and if I use 74, remember it's in between. No. Why? Yes. Okay, yes, there you go. I don't want to start all over again. It's going to take time. So 74, that gives me negative 3,722. And if I check out the difference between the two, so if I have my answer there and I subtract negative 3,601, I get negative 121. So I know with confidence that my answer is right. So yeah, to answer nicely the question that they asked, they said between which two terms. Okay, so between term 73 and term 74, and that's it with 3.3. Now let's check out 3.4. all right, so what value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern formed will be 1? Okay guys, so what stood out for me, what jumped out of the page for me, is the maximum term. Remember, I told you that this is a sad phase parabola that we're looking at, and our maximum term here is actually the turning point. Okay, so what they're saying, what value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern formed will be 1. So I want to know, first of all, what is the value of the turning point, okay, before I see what value I must add such that it will be 1. Okay, and if I'm going to add any value, I'm adding it to the whole thing. So if I need to get to 1 and I need to add something, the whole graph will move by that number. And if I need to go down, again, it will move by that very same term. So we need to find out initially what is the turning point. And we can actually see here, this is 3 marks. Sorry, I haven't been looking at mark allocation. But yeah, so this is 3 marks. So if I were to look at the turning point, remember when you are using y and x's, you would actually say x of the turning point is negative b over 2a. Okay, but this time we don't have x's and y's, we have t and n. Okay, and in this case y would be tn and x would be n. So let's just say n. Turning point, want to know what that value is. Okay, so negative b in this case would be negative 26 because the value for b is 26, and 2 times a got it as negative 1. Okay, so negative 26 divided by negative 2, that will give me 13. Okay, so I know the x value. Okay, so it is 13, and I'm going to plug this term, this number here in the term formula so that I can see what T13 actually is. And I hope I still have, yes, I still have it. Okay, so I can then plug in 13. See why it's important not to delete things, or rather press the on function, rather press AC instead of on, or else you're going to have to start things from scratch. Okay, so if I plug in 13 there, my answer is negative 1. Okay, negative 1. So basically my turning point here is 13 and negative 1. Okay, so now they're saying which value must be added to each term, meaning what shift is required, such that the value of the maximum term in the new number pattern formed will be 1. Okay, so currently I'm at negative 1 and I need to get to 1. So what must happen? If I want to go from negative 1 to 1, I must add 2. Okay, so the value to be added is 2. Okay, and that ends it for question 3. Remember guys, please share with your fellow friends, fellow matric friends, especially if they don't have the memo and they want to know how they did. This is a nice way to actually, reflect, see where you went wrong, fix those errors, especially if next day you're going to be studying courses that require maths. It's good that you know your story now. I know you're done writing and you're thinking, okay, I'm going to relax, but just try to go through it, see where you went wrong, fix those errors so that next day you don't have to meet those challenging mountains again. Okay, and yeah, so like our videos, subscribe to our channel, recommend our videos, and if you want to have a session with us, or rather if you know people who might want to have a session with us, please do visit our website and again visit our website, book an appointment, and you'll find us at www.mvtutors.co.za. I will see you next for question 4. Hello everyone and welcome back to MV Tutors. I'm Tsolo, and as promised I'll be looking at question 4 with you guys. Alright, so yeah, as a reminder, do not forget to like our videos and subscribe to our channel and spread the word to those who actually need it. Alright, sharing is caring. Okay. So question 4, consider the linear pattern 5, 7, and 9. Okay, so linear pattern, think of a straight line graph. Okay, so we have 5, 7, 9, and we can actually see that the difference between these two, or rather the common difference is actually negative 2. Alright, and now already for 4.1 it says determine term 51. Okay, so term 51. First of all, we need to get the actual term formula. So let me just go back a bit there before I jump straight into term 51. Okay, so we have, let's get the term formula, which is A plus N minus 1 D. Okay, so A would be 5, N minus 1, and D would be negative 2. So, oh my goodness, did I say negative? This is positive because clearly we are moving from 5 to 7 to 9. My goodness. Oh my word. Okay, I was thinking of starting the video, but let's just move on. Okay. Yeah, let's not even talk about it. Okay, so we have 2n minus 2 plus 5. All right, so our term formula is 2n plus 3. Again, we can test that. Every time you calculate a tn, please just test if it works. Okay, so if I were to substitute 3 there, 2 times 3 would be 6, plus 3, oh gosh, 2 times 3 would be 6, plus 3 would be 9, and my third term is 9, so this formula works. Okay, so now we're looking for the 51st term. So I'm going to get in there 51 plus 3. Okay, and we are definitely using our calculator, not because we can't calculate, but because we are running out of time and we do not want to make silly errors. So T51 is actually 105. And yeah, that was it. So let's see now. What am I doing? Okay, so we are going to 4.2. All right, calculate the sum of the first 51 terms. So you have the sum formula in your formula sheet. Okay, we have 2a plus n minus 1 d. So this is the sum formula for the arithmetic series. We also have the sum formula for the geometric series. There is no sum formula for the quadratic pattern. I don't know if you've noticed, but yeah. So we are looking for the sum of the first 51 terms. Okay, so we are going to substitute 51 wherever we have n. All right, so 2 times the first term, which is 5, plus 51 minus 1, and the difference is positive 2. Yes. So we're just going to plug everything in the calculator as is. You can simplify it if you want, but yeah. So we have 51 over 2, big bracket. Okay, I'm just going to say 10 there, and I'm going to say 51 minus 1, that's 50, and times 2. Okay, so the sum of the first 51 terms is actually 2,805. Okay, and then now we get to 4.3, where it says write down the expansion of that sigma. I know a lot of people, when they see sigma, they start getting concerned. Guys, please, sigma is not something to be scared of. That's just basically saying the sum of, okay? The sum of, so looking at your specific pattern that you have, whether arithmetic or geometric. So if I take that pattern and I sum up the values from 1 to 5,000, what will I get? Okay, so that's basically what it's saying. Really nothing to be afraid of. Okay, so this is the expression. Okay, the sigma notation. So it says write down the expansion of this sigma notation and show only the first 3 terms and the last term in the expansion. So we're gonna have term 1. Okay, so basically it's that plus 3, but we already have it. Term 1 is actually going to be 5. Okay, term 2 is going to be 7. Term 3 is going to be 9. So how do we get the last term? Okay, first of all, before you even get the last term, how many terms are there? Okay, so if you want to know or calculate the number of terms, basically you're going to take the last term minus the first term, or rather minus 1, minus this n. Let me not say a, lest I confuse you. So you're going to take the last value here, or this value rather, 5,000, okay, minus 1 and plus 1. Okay, so every time you take the value on top minus the value at the bottom and you subtract 1. Sorry, you add 1. Okay, so you add 1 always. Okay, please don't forget that 1 that you add. So in essence we have 5,000 terms. Okay, and basically this last term that we need to calculate, okay, I'm just going to say TL for the last one. So we're going to take 2, 5,000, and we're going to say plus 3. Okay, so that's basically 10,003. That is the last term. Okay, and now they say hence or otherwise calculate this. Okay, all working details must be shown. Okay, so let us attempt it. This is now 4.4. So 4.4, we must calculate this. N is equal to 1, and we have 5,000, 2n plus 3, plus n is equal to 1, 4,999, and now we have negative 2n minus 1. Okay, do you guys remember the sum formula where you have the first term and the last term? Okay, basically this one, or rather let me write it at the bottom there. So they want us to calculate that, and this is the sum, remember. So it's going to be n over 2, the first term plus the last term. We already have the first term for this one, right? And we already have the last term for it as well. Okay, so we can go ahead and calculate it. Okay, so we know that n is going to be 5,000. Okay, because the number of terms, remember the top value minus the bottom value plus 1. So we have 5,000 divided by 2. The first term was 5, and the last term was 10,003. Okay, but now we need to know here how many terms do we have for this sigma notation here. So the number of terms, again, 4,999 plus 1 minus 1 will give me 4,999. And what is the first term? Okay, so if I take negative 2 times 1, negative 1, so that's basically negative 3. Okay, and what is the last term? Okay, so if I take negative 2 and multiply by 4,999 minus 1, okay, let's see on the calculator. So I have negative 2 times 4,999 minus 1. I get negative, okay, I'm gonna write it here, negative 9999. Okay, so I can then use this formula. Okay, so I should say, I should have put it this way. S for 5,000 plus S for 4,999. Okay, so yeah, which will also be equal to n over 2a plus l. Okay, this one is for 5,000 and that one is for 4,999. All right, so again, 4,999 divided by 2. My first term was negative 3. My last term was negative 9999. And now I can then put everything in the calculator and then solve. Okay. So yeah, I have 5,000 all over 2 multiplied by 5 plus 10,003, okay, plus 4,999 divided by 2 multiplied by negative 3 negative 999. Okay, so I get the 20,001. Okay, and yeah, basically that is question 4.4 and question 4 done. Okay, so that was 4 marks. So yeah, we had to work, and you see the previous one was 1 mark because they're pretty much giving you everything that you needed. So I hope you learned something. You saw my mistake there initially when I thought, my goodness, going from 5 to 7, I subtract 2. So also be careful of those silly mistakes when you're writing your paper and going forward. Okay, thank you for tuning in, and it is goodbye from me.
Welcome to MV Tutors. My name is Figa Gashe Manana, and we are still doing the 2021 November Mathematics Exam Paper 1. We're now in question number 5. Now, this is just us trying to do a memo in the most what am I gonna call it, digestible way. Okay, so I hope you will understand at the end of this, but in the event that you don't, please talk to your parents or your guardians about having us as your tutor. I would love to be your tutor. You can contact me on my website www.mvtutors.co.za, or just simply WhatsApp me on 076-312-1107. Well, if this is what you want to do today, question number 5, you came to the right place, because I'm going to explain it to you in the most simplest of ways. Let's get right into it. Question 5, given this function, what is this function? If you said hyperbole, then you are right, correct. This is a hyperbole. Now, there's a few things we know about a hyperbole, especially given in this manner, is that these are the asymptotes right there. But let's go to the question and see what they want. So, question 5.1, let's start right there. Write down the equations of the asymptotes of f. Oh, okay. So, this one here, as you know, theoretically, it gives us the x asymptote, and you always take the opposite sign. So it's given in -3, so it's +3. That's the asymptote. And then for the y you take it exactly as it is. So it's a +2, just like that. Cool, that's all. And then 5.3, write down the domain of f. 5.2. So the domain, remember, domain has to do with the x, and x is an element, and we have an asymptote at 3, meaning it doesn't include 3. So it starts from -infinity, and infinity, you always put it with a curved bracket, all the way up to 3, because it doesn't include 3, so we put a bracket as well. And then u, which means it also includes this, from 3 once again to +infinity. That's it. Okay, next question, 5.3, determine the coordinates of the x-intercept. Cool. To solve x-intercept, you always say let y equals 0. It doesn't matter what that function is. It can be quadratic, it can be a straight line, hyperbole. You're always going to say let y equals 0 to solve for your x-intercept. So the function is going to be 0 is equals to -1 over x minus 3 plus 2. Okay, so what I'm going to do is take the 2 to the other side, and then it becomes -2. And then also multiply both sides with this as well, which is x minus 3 x minus 3, and that's gonna be equals to, we're gonna be left with minus 1 this side. So just multiply this in. Minus 2 times x, I get minus 2x. Minus 2 times minus 3, I get a positive 6, and it's going to be equals to minus 1. I'll take it to the other side, then it becomes minus 2x is equals to minus 7. Okay, so get more space. Divide both sides by minus 2, and I get my answer is x is equals to minus 7 of, you know what, I need a calculator. Excuse me, I need a calculator. So that's gonna be 7 divided by 2. Okay, so I need it in decimal. That's 3.5. So coordinate always comes with x and y, so the x value is 3.5, y value is 0. Okay, that's how you write coordinates. Okay, let's see the next question. Write down the coordinates of the y-intercept. Okay, so for the y-intercept, you do the opposite. You say let x equals 0 this time. So then we'll have a function as y is equals to minus 1 over 0 minus 3 plus 2. So what I have here then is really, these are positive because they cancel each other, the negative values. So I'm just going to put this in a calculator. I don't want to waste time. You should just put it in a calculator yourself, because under exam stress it's very easy to make a mistake. So that's like 2.3. That's our y value. So let's set coordinates cover x and y. So the x is 0 and the y is 2.3. Okay, thank you so much, calculator. And then it says draw the graph of f, clearly show all asymptotes. Okay, now we're gonna draw this graph with our values there. Okay, so you get yourself a ruler. Okay, we need it. Let's draw a horizontal line first. I mean a vertical one. We need 90 degrees. So I'm just gonna draw it right there in the middle. Let's make it black. There we go. And then we need a horizontal line for real now. Okay, so horizontal line right over there. Show it right over there. It's cool. Okay, cool. Now what do we want? The next thing that we should put really is our asymptotes. The first one, the y is 2, so let's say 2 is somewhere up there. I'll use a different color. Okay, so that's our asymptote at 2. And then x3, we've got another one at x3. Okay, so that one is vertical. Let's just say 3 is here. Okay, so we'll put our other asymptote here. Cool, there we go. All right, thank you so much. And then our values, this is it's passing here at we said 2. This one is at 3. Next thing we need is the y-intercept. So the y-intercept is this one, 0 and 2.3. So it's really, it's up here. Let's say that's 2.3. And then the x-intercept, it's 0. I mean, it's 3.5 and 0. So let's just say 3.5 is right over here. It's going to be at 3.5. Next thing is that to draw the graph. Now this is a negative graph, so it must be on the second and the quadrant number 4. Okay, so remember the graph pretends to reach the asymptote but never touches it, and then it passes the y-intercept, continues all the way up like that. Okay, and also this side as well, it does the same. It must pass as if it's gonna touch the asymptote, but it doesn't. And also this side, it goes as if it's gonna touch it, but it doesn't, and it goes all the way there. And ladies and gentlemen, this is our f of x graph. And that's it. That's how you draw it. Okay, if you didn't understand anything here or you need further explanation, you know what to do. You know where to contact me. Visit my website or WhatsApp me. I'll be ready for you. And remember, always include your guardian or your parent in the decision or before contacting me. Thank you so much.
Hello everyone and welcome to MB Tutors. I'm Solo and I'll be looking at question 6 with you guys. We're still doing paper 1, Maths 2021 November exam. Okay, so let us see and get right to it. And please don't forget to like our videos, subscribe to our channel, spread the word to your fellow friends and fellow matrics. Yeah, I know you guys are done, but you don't know how far word of mouth can get and how it can assist the grade 11s that are going to be in matric next year. So please spread the word. Now question 6. Okay, I'm just gonna zoom in a bit. All right. So it says the graph of f of x is equal to log 4x, okay, or log base 4x, drawn below, okay? And then b is a point on f, all right? And then firstly, they want us to calculate the value of k, that's 6.1. So what are we going to do there? Well, we have our equation, which says f of x is equal to log log base 4x. Okay, and we can then substitute the point b inside the equation. So the y value will be 2 and the x value will be k. Okay, and right now we're just going to solve using our logs, okay, what k is. So there's a simpler way of doing it. I'm just going to do it in a less commonly used way. Okay, so we have 2 this side, right? So if you have log k or log base 4k, you can rewrite it like this. So you have log k divided by log 4. Okay, and I take the constant to the left side, so I actually have 2 log 4, or 2 times log 4 is equal to log k. And then I take everything to the, like I use 10 to the power my answer. Why? Because if I say 10 to the power log, that actually gives me 1. Okay, so that's what I'm going to use here. All right, so I will then have, let me just shift it a bit up so that we're not restricted. Okay, so then I am going to say 10 to the power 2 log 4. Remember, 4 is no longer a base now, everything is just on a straight line. Okay, and then it's equal to 10 to the power log k. Okay, and Yeah, so now if we have, using our calculator, let me just shift it that side. Okay, so I have 10 to the power 2 log 4, and that gives me 16. Okay, and then this side, the 10 and the log cancel, so I have k. So basically, ultimately, k is equal to 16. Now I know it's a long route. You probably know a shorter way of doing it, but this is me showing you an alternative to what you are used to. Okay, so that is 6.1. And now 6.2, we're going to answer it also in a similar manner. Okay, so what does 6.2 say? Determine the values of x for which the function of x is in between -1 and 2. Okay, so -1 is also included, and in between 2, -1 and 2. And we know that we have log base 4 x. So I'm going to do the same thing that I did previously. Okay, so I have log x divided by log 4. Okay, I'm going to multiply both sides with log 4. Okay, so this side I'm going to have log 4 times -1, which is just negative log 4. Here I have log x, and there I have log 2 log 4. Okay. All right, and then because I want to get rid of these logs, or rather on the ends, we can actually get the values there. So if I have negative log 4, that's actually negative 0.6. So negative 0.602, and I have log x. On this side, I have 2 log 4. Okay, and that gives me 1,204. Okay, so for me to get rid of this log over here so that I can just have x and determine the value of x, I'm going to take everything and put it as an exponent. So I have an exponent to 10. So I have 10 to the power negative 0.602. Okay, and then I have log, yeah, hey. I have 10 to the power log x, and I have 10 to the power 1,204. Okay, so if I say 10 to the power this answer, I'm going to get 16, right? We already solved it before. And here the 10 cancels the log, so we have x over there, and then we're going to have 10 to the power, let me just go up there. So if I have this one, if I say 10 to the power the answer, I'm going to get 1/4. So we have successfully answered 6.2. We've determined the values of x. Okay, and this probably wasn't a lot of marks. I can't see the mark allocation at the moment, but yeah, as long as you get the answer. All right, so I might be showing, like I said, I might be showing a longer route, but it's a route that you understand what's actually going on. Okay, now we go to 6.3. Okay, so it says write down the equation of the inverse of f, okay, in the form y is equal to. So we know that f is equal to log base 4 x, log x base 4, however you want to say it. So I'm just going to say y is equal to log 4x. Okay, and now we're looking for the inverse. Okay guys, so when we're looking for the inverse, you're going to actually swap the x and y values. Okay, so now we're going to have x this side, and it's going to be log 4y. And now we need to write this equation in terms of y. Okay, so again, I'm going to continue with the way I've started. Log y over log 4 is equal to x. Okay, then I'm going to have, let me just put the y this side. Log y is equal to x log 4. And then if I bring in 10, let me just shift this page up. Okay, let's bring that a little bit lower. Okay, so if I say 10 to the power log y is equal to 10 to the power x log 4. So this would cancel. I have y that's left over. Okay, and then what I can do there, this would work out not like that. Definitely not like that. It should be y is equal to 4. Oh, you know what I can do? I know what the answer should be. It's just a matter of writing it. So if I have x log 4, remember, you can always take the coefficient. Sorry, let me just delete that. You can always take the coefficient of the log and make it a power. Okay, so we have 10 and I have 4 log 4 to the power x. I can take this to the other side. Okay, and then the 10 and the log cancel. So finally I have y is equal to 4 to the power x. I'm just showing you an alternative way, guys. You know the easier way, but just in case you get lost, this always works. Okay, and then lastly, 6.4. This was a very short question. I see they really shortened the questions, which I think is nice, so that, you know, if hope ideally you can go forward and then come back to it later on. Okay, so now 6.4, for which values of x will x times the inverse of x be smaller than 0? So we have x, right? And we're multiplying it by the inverse of x, which is 4 to the power x. And that is going to be smaller than 0. If you were to sketch for yourself what y is equal to 4 to the power x looks like, well, basically it's a graph like this. Okay, where the x-axis acts as your asymptote, and on the y-axis the graph can really just go on and on and on up there. Okay, but your range is limited to the x-axis up until positive infinity, so it can't go to the negative side. Okay, so yeah, here you have your inverse. Okay, so x, so which values of x will this be less than 0? Well, your answer will definitely be x smaller. Why does this thing do that? Okay, let's just go back a bit. Okay, so maybe it's the way I write my x, or not. Okay, so x will be smaller than 0. Okay, so this is the portion I'm looking at. But here, this graph here, 4 to the power x, as we've seen here, it can never, ever cross the x-axis, meaning it can never really be negative. So even if you said 4 to the power x smaller than 0, like, it can't. There's no way. It can't happen. Okay, so yeah, maybe you can write a note there that 4 to the power x, how do you put it? It will never be negative. Yeah, never. It'll never be negative. Or you could say it will never be smaller than 0. Okay, and that is it for question 6. I'll see you guys for question 7, and it is it from me. Bye. Alright, hello everyone and welcome back to MB Tutors. I'm Tulu and I'll be looking at question 7 with you guys. So without further ado, let's get right to it. Okay, so what do they want from us? Okay, so the graph of f of x is drawn below. We can see it's a parabola and they've given us the equation. And they say the parabola cuts the x-axis at B and D. Okay, so those are your x-intercepts. And the y-axis at G, so that is your y-intercept. C is the turning point of f. Okay, we see it. It's actually down there. It's a happy face parabola, so you have a minimum value. Okay, if you had a sad face parabola, you would have a maximum value at the turning point. Alright, then it says line AE has an angle of inclination of theta and cuts the x-axis and the y-axis at A and E respectively. T is a point on F. Okay, so there is T, which is in between B and G. Okay, so first question, write down the coordinates of B and D. So first of all, we need to recognize that B and D are the x-intercepts. Okay, and at the x-intercept, that is where you have y being equal to 0. Okay, so in your equation, instead of y, you're going to put 0 there. Okay, then you're going to have x plus 4 and x minus 6. So when you solve it, x is equal to negative 4 or x is equal to 6. Okay, so we can then see that B actually goes with negative 4. So B is negative 4 and 0 for the y coordinate, and then D, that's where you have 6 and 0. Okay, those are your coordinates for B and D. Now for 7.2, they actually want the coordinates of C, so that is the turning point. Okay, so with the turning point, you can use the formula or you can just look graphically, okay, where the x-axis is. So what the x coordinate of C would be, you can look at it graphically, okay, graphically. All right, so I'm just gonna say x for C. All right, I'm gonna use the equation. I have negative b over 2a. Okay, but the way our equation is written, it's not actually multiplied out, so let me just multiply it out quickly. Okay, you see the mark allocation here is quite low, 2 marks, so I'm doing a lot more than is required, but whatever works for you and whatever is quickest for you. For me, this is quick. Okay, so I have plus 4x minus 6x, I'm going to have negative 2x, and then I'm going to have negative 24. So my b value in this case is negative 2. Okay, so I actually have, what did I do there? I actually have negative 2, okay, and the a value is 1. Okay, so now I know that my x coordinate for C is going to be 1. Now what do we do to get the y coordinate? You simply substitute 1 in, okay, into the equation. So I have 1 squared, then I have negative 2 times x, which is times 1. So I'm not going to bother writing that down. So I have 1 minus 2, which is minus 1, minus 1 minus 24, that gives me minus 25. So therefore I can say with confidence that C is 1 and negative 25, and it should be a negative. Remember, with a sad face parabola, you have a minimum. Sorry, with a happy face parabola, we have a minimum, and C is in the region where y is negative. So yeah, okay. And then now let's see what does 7.3 want. So it wants us to write down the range of f. So you know that C is your minimum, okay? So when you get the range, y will be an element of the minimum that you have there, okay, is negative 25. And the maximum, well, it can go on and on and on. So we're going to have infinity. And remember, with the infinity sign, it must always be accompanied by a round bracket. Please do not put a square bracket, because you don't know exactly what the value of infinity is. Okay. And then 7.4, they tell us that they give us the angle of inclination, which is 14,04. And then they say, and the tangent to F at T is perpendicular to AE. Okay, so let's just see what does 7.4.1 require from us. We need to calculate the gradient of AE, correct to 2 decimal places. Okay, so 7.4.1, if we need to get the gradient, remember the gradient AE, if we've been given the angle of inclination, we can use this formula. Okay, gradient is equal to tan theta. So they've given us the angle of inclination, which is 14,04 degrees. Okay, so we can then calculate that. Yeah, calculated. So it's actually 0,25. You can also put it in a fraction form. We know that that is a quarter. Okay, and then 7.4.2, let's just move the page a bit up. Okay, so 7.4.2, calculate the coordinates of t. Okay guys, what is happening here? So they said there's a tangent line, right? And this tangent line, it passes through A and E, and it's actually perpendicular to A and E, or the line AE. Okay, so if I were to like sketch it in, let's see, how would we do it? Okay, so there's a tangent at T. Okay, so it would go something like, no, not like that, but no, definitely not like that. But yeah, something like that. Let's try again. Okay, so let us draw. Maybe let me use this thick one and make it red. Okay, so it would look something like this. Okay, so yeah, and this line is actually perpendicular to AE. Okay, so now they want the coordinates of T. Do we have the equation of AE? No, we don't. We don't even have its intercepts really. We just know that the intercepts are at A and E. And do we have anything regarding T? We don't have, we're looking for the coordinates of T. So what I would suggest, we would have to use a little bit of calculus. Because if we had the equation that passes through T, if we had the tangent equation, we would equate it to the parabolic equation, okay, the quadratic equation. And there where T is, okay, that would be the common point, and we'd calculate the coordinates. But this is not the case. We don't have that much information. So what I would suggest is, using calculus, we can get the gradient of that tangent line. Okay, so I'm going to say gradient of T. And since this line is perpendicular to AE, I know that the gradient of T and the gradient of AE, when I multiply them, I need to get -1. So I know that AE, the gradient of AE is already a quarter. So now it means the gradient of T will be -4. So if I say -4 times a quarter, I'm going to get -1. Okay, so now after getting this gradient, what do? We know that if we take the first derivative, we can actually, that's actually equal to the gradient. Okay, so our equation, let's just go a little bit up to see it. It was x squared minus 2x minus 24. Okay, so let's just remind ourselves, put it on the side. We had x squared minus 2x minus 24. So if I take the first derivative, I know it's going to be 2x. So remember, we bring down this 2. It becomes the coefficient of x, and we subtract 1. So we have x to the power 1, which we're not really going to write. Okay, and then secondly, we have 1 there, right? So we bring it down. It's going to be -2, and then we subtract 1. So this is going to be 0. X to the power 0 is 1. So we're not going to include it there. And this is a constant. If we differentiate a constant, it's just 0. Okay, so we have 2x minus 2. And we know the gradient is minus 4. So we can actually work out what x is. So if I take 2 to the right hand side of the equation, or the equal sign, I'm going to get minus 2. I'm going to get minus 4 plus 2, which will be minus 2. And then x will be minus 1. Okay, but we're not done. We just got the x value for t. We need to take this very same x that we just solved, and we need to substitute it in the original equation. Okay, so we're gonna just swing it by over there, and we're gonna then find out. So we have negative 1 squared minus 2, okay, minus 2 minus 1 and minus 24. Okay, so we have 1 plus 2 minus 24, and we are getting 3 minus 24, which is minus 21. And that sort of makes sense. I mean, if C has a y value of minus 25, T should be, above. So minus 21 actually makes sense. So ultimately, the coordinates of T would be minus 1 and negative 21. Okay. So now we are going over to question 7.5. Okay, I'm just going to remove what we did there. We don't want to save it. It's all good. Plus we want to zoom in. Okay, there we go. So now 7.5, a straight line G parallel to AE cuts F at K and R. Okay, let's see what is happening. So a straight line G parallel to AE cuts F at K is equal to, so K is minus 3 and 9. Okay, I'm going to have to sketch again. Okay, so we have a parallel line that cuts F at K. Okay, so K, I mean, if T is minus 1, K should be somewhere around here, I'm assuming. So I would, so thick. So I would assume that that is where K is. Okay, let's actually make it a little bit thin, and let's use red. So this is K with the coordinates. Yeah, no, like, you know what, it's fine. Maybe let's just use the pencil and let's erase all of this. Okay, so we have K there, and K is negative 3 and negative 9. Okay, it's really not to scale. If it were, it would probably be somewhere above, seeing that C is a whole 25 units. Okay, so now what do they want? So we have a parallel line cuts at, and R. Where is R? We calculate the x coordinate of R. So anyway, if we were to draw a straight line, I'm really going to struggle here, but please bear with me. A parallel one at that. Okay, so let me attempt again. So parallel line. Okay, we tried. Okay, so it's parallel to AE. What else do we know? Straight line G cuts F at O. Okay, so R is another point on F. Okay, so there is R. And now we need to determine the coordinates of R. Okay, so here we already have the gradient of AE, and we know that if lines are parallel, the gradients are the same. Okay, so I'm going to start by saying the gradient of KR is equal to the gradient of AE, which is a quarter, right? And then we can get the equation for KR. Okay, so we already have a gradient for KR, and we have a point. All right, so y is equal to mx plus c, and we can then put it there. We have a point K, which is minus 3 minus 9. So the y value would be minus 9. the gradient is a quarter, the x value is -3, and we have plus c. So c is equal to -9. Then we have -3 times the quarter, which is -3/4. If we take it to the other side, it's going to be +3/4. Okay, so that's 0.75. So now we take -9 plus 0.75. It's going to be -8.25. Okay, let's just check on the calculator. Okay, so we have -9 plus 0.75. Okay, yeah, -8.25. Okay, cool. So now we can actually get the equation. Okay, so y for kr, the equation, it's actually equal to a quarter x minus 8.25. Okay, so we have our equation for for kr. What we can do, we can then equate the parabolic equation. Okay, we can equate that one to the straight line, because we have those common points, right? So we have r there, we have k there, so they intersect there, so we can make both equations equal. Okay, so just to remind ourselves, what is f of x? If I remember correctly, it is x squared minus 2x minus 24. So I can equate these two equations. So I have a quarter x minus 8.25 is equal to x squared minus 2x minus 24. All right, so I take everything to one side. How many marks is this, by the way? Because yeah, we're about to work. Okay, doesn't matter. So if I take everything to the other side, I have x squared. Now I have minus 2x. If I bring a quarter x to the right hand side, it's going to be negative, right? Negative a quarter. So it's actually going to be -2.25x. And then I have minus 24. Okay, so minus 24 plus 8.25. So I have these values. I have -15.75. Okay, so I can actually, maybe I'm complicating life, but I want to actually calculate everything, multiply everything by 4. Okay, so I have 63 here, -63, and if I say 2.25 times 4, I want whole numbers. I know you guys like the quadratic equation, and you know what? It's actually a great idea to use it, but I just prefer this method. Okay, so what do we have here? We have x squared minus 9x minus 63. So I know I'll have x here and x there. Now what are the factors of 63? I know I have 1 and 63. That will not give me 9. I have 3 and something. So 63 divided by 3. I have 3 and 21. That will not give me 9. 4, no. 5, no. 6, no. 7, maybe. Let's see. 63 divided by 7. Yes, I have 7 and 9. Okay, that still does not give me 9. Oh snap, you know what? I've multiplied everything by 4. And then I forgot to put a 4 there. Now this method is coming back to bite me. Okay, am I going to use 4 and 1 or 2 and 2? Okay, this is becoming unexpectedly challenging now. Okay, should I use 4 or should I use 2? Okay, which one is better to use? I think I'm going to go with the quadratic equation. I'm going to complicate my life if I do this any further. Okay, sorry about that. Okay, so yeah, let's just use the quadratic equation. So x is equal to b minus 9 plus minus, so b squared minus 9 squared minus 4ac, okay, and that is all over 2a. Okay, yeah, this is way quicker. I wasted time unnecessarily because I was trying to be smart. So I have 9 plus, so I have 81 minus 16 times negative 63 all over 8. Okay, so my first answer will be 5,25. Okay, or I will have minus the negative 3. X is equal to negative 3. Alright, so we are getting somewhere, guys. Okay, so I see k. This is the k value, the x value for k. So we're not really looking for k. We already have k. I'm not going to continue with that. Okay, so we're not going to look at that one. We're going to focus on 5,25. Okay, so what is the y value? If I take 5,25 and plug it in the equation, what will I get? So I have 5,25 squared minus 2 times 5,25. Alright, and then I will have minus 24. So the y value is negative 6,94. That does not make sense. Oh, okay, maybe it's the way I drew it. Maybe it's the way I drew it. Maybe this thing is like somewhere below here. Okay, so maybe this thing is like that. Okay, so the way I drew it is incorrect. This would be how it is. So r would then be 5,25 negative 6,94. Okay, and that is it. I don't know, is it it? Yeah, that's it for question 7. Sorry guys for taking up your time. Use the quadratic formula. It is easy, it is straightforward, it is quick, and it will give you the right answer. Don't try to be smart like me. It wasn't working out. And guys, again, please share these videos with your friends, or those in grade 11 who are about to go into grade 12. You guys are done, so just check yourselves and prepare for next year if you're going to continue with maths. So yeah, that's it from me. Don't forget to like our videos and subscribe to our channel. Thank you. Hello everyone, and welcome to MB Tutors. I'm Tsolo, and I'll be looking at question 8 with you guys. Please remember to like our videos and subscribe to our channel. Also share this information with those who are in need. Alright, especially the grade 11s that are going to be in matric next year. They need to know where to find the resources, so please spread the word. So, question 8. This is financial maths. So it says, a farmer bought a tractor for 980,000. The value of the tractor depreciates annually at a rate of 9.2% per annum on the reducing balance method. Calculate the book value of the tractor after 7 years. Okay, this is 8.1. Okay, so let us get to it. Let us do it. So 8.1. So the reducing balancing Yes, the reducing balance method. It's basically this formula here, but you have a negative, okay, interest, and it's compounded, okay, it's not simple interest. So we know the value of the tractor is 980,000, all right, and it depreciates annually. So they've given us the annual depreciation rate. There's no need to divide by anything because it's not monthly or anything like that. And the years in which it depreciates is 7 years. So we want to know what the value of the tractor will be after, or rather the book value. Okay, so what we're going to do now is say 980,000 multiplied by 1 minus, I'm so used to adding here, 9.2%, okay, all to the power of 7. So yeah, it depreciates by so much. But that just shows you, even when you buy expensive cars, well, the moment you take it out of the store, it has already depreciated. So yeah, think twice about buying very expensive cars at a young age. Okay, unless if you buy these old cars that are vintage. I didn't know that they actually appreciate with time, they don't depreciate. So maybe you could do that rather. But please, when you are young, don't go for these expensive cars. Invest in things that appreciate, not depreciate. Okay, that is my little advice. So that was 8.1. Now let's see, for 8.2, how many years will it take for an amount of 75,000 to accrue to 116,253 Rand and 50 cents in an account earning interest of 6.8% per annum compounded quarterly? Ooh, score. Okay, so that's now 8.2. So what do we have? Let me just write down the information we have. So we know that we have an amount of 75,000, right? And this will accrue or will accumulate to 116. We have 253 and we have 50. And in an account with that interest, so we have 6.8% per annum compounded quarterly. So how many years? So when we have our years, because we have quarterly there, we're going to have to multiply. I'm just going to say, I'm going to use y. So we have 4y, right? So if you want to get the amount of quarters in a year, we're going to have to multiply by 4. Okay. Yeah, or rather, let me just put it this way. It's weird if I put y. We're so used to y being something else. So let me say the years, all right, the quarters, because it's compounded quarterly. Time, right, in quarters. So that'll just be 4 times n, because n, they normally give it to you in years, but now we're going to have to calculate first in quarters, and then afterwards we're going to take it back to years because they want it in years. Okay, so now what is the formula we're going to use? All right, same story. This is not an annuity. So if it's not an annuity, then we're going to use this formula here. Okay, but instead of a minus like we did previously, it's going to be a plus. Okay, so we know that it accrued to 116,253,5. Okay, and we have 75,000. All right, and then we have 1 plus 6.8% divided by 4, and we know that we have 4 in there. Okay, so now we're just going to do some mathematics there. We have 253 over 5, and we're dividing by 75,000. Okay, and then we have in brackets 1 plus 6,8 over 4 to the power 4n. So if I want 4n to be the subject of the formula, I have to use logs. Okay, this would be my base. So base 1 plus 6,8% over 4, and this is what I would write then next to it. So 116,253,5 all over 75,000. Okay, so the number of quarters, let's just take out the calculator. So the number of quarters, we have log, okay, let me use the other one. Yes, this one, log. So in brackets there, we have 1 plus. So I use all the values because I don't want to use rounded off numbers. Okay, so it's going to be long. Okay, and there we have 116,253,5 all over 75,000. Okay. Oh snap, I used the 2 there. It's supposed to be 4. Okay, so now we have 25,99999, so we're just going to round it up to 26. So we have 26 quarters. Okay, they did not ask us for quarters, they asked us for years. So n will be 26 divided by 4 years. Okay, and now we need to go and see what that value is. So if I say this divide by 4, it's 6.5 years. And that actually does make sense. Okay, with that interest rate, it makes sense. 6.5 years for you to go from 75,000 to 116,000. Okay, awesome. Now let us go to 8.3. Okay, so 8.3. Tabo wanted to save 450 as a deposit to buy a house on the 30th of June. Okay, so that is his goal. Okay, the 45,000. Now, okay, 8.3.1. He deposited a fixed amount of money at the end of every month into an account earning interest of 8.35% per annum compounded monthly. So I know my interest rate there is 8.35% compounded monthly. His first deposit was made on the 31st of July 2013 and his 60th deposit on the 30th of June 2018. So I know that 60 months, right? Because he's doing it on a monthly basis. Okay, so then will be 60 months. And we are compounding monthly. All right, and then calculate the amount he deposited monthly. So we're basically looking for X. So now, are we going to use the future value equation or are we going to use the present value equation? Thing is, he wants to save 450 for a deposit. So his future value amount is 450,000. So we're going to use the future value equation. If it were the present value equation, then he would have received money immediately, probably in a form of a loan or in a form of a trust fund or anything like that. Okay, so I just want to check out what the formula is. All right, so future value. Okay, so this is like the info that we're going to use. I normally put it on the side. So the future value equation, if I remember correctly, I'll check myself if I'm correct. So this is the future value equation. All right, and then he wants to save 450,000. Okay, we want to know on a monthly basis how much should he have to contribute. Okay, so we have 450,000. We want to know what the X value is. Okay, so I have 1 plus 8.35% over 12 all to the power of 60 minus 1, and that is all divided by 8.35% divided by 12, which is the interest. So yeah, quite a hectic one. So x is pretty much going to be 450,000 divided by all of that. Let me put all of that in the calculator so that we can just calculate it. All right, so we have 1 plus 8.35% divided by 12 all to the power of 60, and then subtract 1, okay, and close the bracket. At the bottom we have 8.35%, okay, divided by 12, and what happened now? Oh, okay, let me remove this bracket here. Okay, so we have 74.15. Okay, when you get that value, please do not remove it, just keep it on the calculator. All right, so now we're going to say 450, 1, 2, 3, divided by the answer. So I get the amount. So he actually needs to save 6,068.69. Yeah, I think that is doable. I mean, 60 months is what, 5 years? Think about it this way. If you were to buy a polo, some golf, I don't know, probably cost around 450K. I've heard people who have those cars, they pay around this monthly installment. So it makes sense. Sometimes it helps to actually know what kind of amount you're expecting, so that if an answer seems like it's just not right, you can feel it, man, this answer is just not right. Yeah, it can work out that way, but I mean, I guess it comes with experience. Knowing here and there if you've actually had to take out a loan. But yeah, so him with this, I mean, this interest rate is also with the savings or investment, you'd want something higher than 10%, but it's not always possible. So with this interest, you can expect around 6,000 monthly payments to get 450 in 5 years. Alrighty, so now 8.3.2, Tabo bought a house costing 1.5 million and used his savings as a deposit. Okay, so if he used it as a deposit, it means when he's asking, okay, let's read. He obtained a home loan, all right, for the balance of the purchase price at an interest rate of 12. It's sad that when you want to invest or save, the interest rate is so little. Yet when you borrow money from the bank, my goodness, they are killing it. They are charging 12% per annum compounded monthly over 25 years. Can you imagine the interest? Now he made his first monthly installment of 11,058.85 towards the loan on the 31st of July. Okay, so what will be the balance outstanding on the loan, all right, on the 30th of June 2039? So they actually tell us 21 years after the loan was granted, what will be the outstanding balance. So basically, we have N is equal to 21 years. Okay, 21 years times 12, that will give us 252 months. Okay, and then his monthly installment is what, 11,058.85. Okay, and also what else did they give us? Oh, we need to know the present value. So what will be the loan amount? Okay, so he wanted to buy a house for 1.5 million, and we need to subtract that 450 that he saved, So his present value, or the loan amount, is actually going to be, so 1, 2, 3 minus 450. Yeah, something went wrong here. Did I put an extra 0? So 1, yes, I did put an extra 0. Okay, so 1050000. Okay, so yeah. And what are we looking for? We are looking for the outstanding balance. Okay, guys, so the outstanding balance, oh, the interest, I forgot about the interest. The interest is 12% per annum compounded monthly. Okay, so the equation for outstanding balance, I'm just going to say OB. Well, basically, it is like taking, so this loan that they have given him, remember there's an interest that is applied to it, okay, for that certain amount of time. So you need to factor in this, okay, and then you need to subtract the monthly payments that he has been making. Okay, I'm going to use the future value equation. Okay, so yeah, this amount that he is actually borrowing from the bank is 1,050,000. Okay, and 1 plus the interest rate, I'm just going to say 1%. Okay, and the amount of months, 252, and then we're going to subtract by the future value. Okay, we already have the equation there. Remember, it is x 1 plus I to the power n minus 1 all over I. So the x, the monthly payment is 11,058,85. Is everything going to fit? 1 plus 1%, 252 minus 1, all of that is closed up, and then all over 1%. Okay, let us work it out. So we have 1,050,000. 53 zeros. Okay, so we have 1 plus 1% to the power 252. Okay, so we have here is a 12 million 887. Do you see how much the bank, hey, when you buy a R1,000,000 house, they're already making $1 million. More than $1 million, 12 million. Okay, and then we have that future value amount, so it is 11,058, okay, comma 85, and I have 1 plus 1% to the power 252 minus 1, and then we have 1%. Okay, so that is 1,343,000. No, that's 13 million. Okay, now something isn't working out properly here. What did I do? Oh, did I subtract 1 in the power? Okay, 252 space minus 1. Okay, yeah, but it's still a lot. So I have 11, let's see the amount, 11,058,85. Oh, brackets, guys, yo, brackets. Okay, we need to put a big bracket here, and we need to put another big bracket over there. See, now when you don't put brackets, the mess that it makes. Okay, So I have 12, 4, 6, 7, 7, 4, 9,81. Okay, so now we're gonna take 12, 887, 702, 2, and I'm gonna subtract the answer. So I get 419, 952, 39. Okay, and then so that is the outstanding balance. Okay, ish, imagine after paying for so long, so many millions, and now you still have another 420,000 to go. Yo, I know it's rough out there. Okay, so that's A, ne? And then almost there, guys. B, calculate the interest Tabo will have paid over the first 21 years of the loan. So what is the interest amount, guys? Okay, what is this interest? So basically, he has been paying the monthly payments. Let's first start with that before I even calculate the interest. What has he paid so far? Okay, he has paid 11,058,85 times 252. Okay, that's the amount he's been paying diligently. Okay, so 11,058,85 times 252. And okay, so he has paid 2,786,830, 2. But there has been so actually to now get your interest, you are going to take, okay, so you're going to take the installments that has been paying, which is the 2 million, okay, minus the loan, okay, and then minus, it's like I'm in a hurry to finish now, minus that 419. Okay, the outstanding balance. Let me just say outstanding balance, so that we can see what interest he's actually been paying. So those installments amounted to 2,786,830 rands and 20 cents, minus the loan amount, which is 1,050,000, plus the outstanding balance 419,952,39. Okay, let's just take this, move it up, and then we can get our amount. So we have our answer here, minus the 1,050,000 plus the 419,952,39. Sure, yeah, he's been paying a lot. So the interest that this guy, it's not even done yet. The house hasn't been paid up yet. So it's 2,156,782 rands and 59 cents. Guys, this is a lot. This is a lot of money, but what can we do? What can we do? It is what it is. And with that, guys, I say goodbye. We are done with some finances. Thank you very much. I hope you learned something. I hope you become wise in your finances as well. Please let it not be the last time you learn about how to handle your money. You will see when you start working that you know what, this adulting life is actually not easy. So learn to master your finances now. If you can invest, please, please, please do that. Okay, so that you can actually buy property cash. Okay, you can even follow this lady called the Financial Bunny. She learned how to get enough money to buy properties cash, and you can listen to her as to how to do that. Okay, we're still learning. Okay, we are unlearning this thing of relying on banks and learning how to buy things cash, and it's not easy. It requires patience. So yeah, stay smart. Apply these things that you're learning in school and enjoy your holidays. I will see you guys. Question 12.
Well, good day to you. My name is Figagashe Manana, and welcome to MV Tutors. Well, we're still doing the 2021 November exam, mathematics. You just wrote this a few weeks ago, so this is a memo just to help you, find out how you did. Okay, so now this is not the official memo taken up by the department, but we fairly confident that our answers are correct because 2 plus 2 is still 4. Mathematics is a universal language that's the same everywhere you go. So anyway, let's get right into it. We're now doing question number 9. Okay, so let's do question 9.1 now. So 9.1 says determine the first derivative from first principles if it is given that f of x is that. Okay, so we know that the first derivative is given by the limit as h turns to 0 of f of x plus h minus f of x, and that divided by h. So what I want to do now is just take this part of it and just solve it on its own. I just want to solve f of x plus h on its own. So it means where there's an x in this equation, I'm going to put x plus h. So for example, it's 2 times x plus h. Now it should be squared, but instead of squaring it, I just want to put 2 of them because I want to solve it right away. Okay, minus 3, and then we've got an x, so I'll put x plus h. Cool, let's go right ahead. X times x is x squared. X times h is plus xh plus, and then this one again is xh, and then h times h is h squared. Now I need to multiply this one. Minus 3 times x is minus 3x. Minus 3 times h is minus 3h. Cool, let us continue in that trajectory. So this one is going to be 2x squared. I'm just multiplying the 2 in. So x plus h plus x plus h is 2xh, and then times this 2 that's outside is going to give me 4xh, and then this one is going to be plus 2h squared, and then this one once again minus 3x minus 3h, just like that. Let's give ourselves some more space. I need some more space to write. Okay, there we go. What can we do now? Is it in its simplest form? It looks like it. So what I'm gonna do is that I'm gonna take this whole thing and substitute it back into this equation so that I would have that. Unfortunately, I have to write the limit thing again. Okay, so f of x plus h, I'll write this whole thing. We just solved it. Plus 4xh plus 2h squared minus 3x minus 3h, and all of this is divided by h. But hold on a minute, do you see there's a minus f of x? So a minus f of x is that. So I'm just gonna multiply the negative in already, so that I'll have minus 2x squared, and then this one is gonna be plus 3x. Okay, it's gonna be plus 3x. What did I just do? It's not what I want to do. I just want to finish that x up here. Okay, it's 3x, and then we can continue in that trajectory. Fortunately, I keep having to write this thing. So 2x here, and minus that one minus that one gives me a 0. What other like terms do I have? Okay, that one cancels with that one too, so that's 0 minus 3x plus 3x, and then I'm left with 4xh plus 2h squared minus 3h. That's what's left unticked, and all of this is divided by h. Okay, still moving forward. Fortunately, still have to write this again because we haven't substituted yet. So what I'm going to do is factorize this. I'll take out what's common is h, and then I'm left with 4x, and then here it's gonna be plus 2h, and then minus 3, just like that. And all of this is still divided by h. These h's cancel each other, and then finally I'm gonna substitute the 0 where there's an h, so I can drop the limit sign now, and then I'll have 4x plus 2h, I'll put a 0 substitution, minus 3, and my final answer is 4x minus 3. That is my first derivative. We are finished with this one. Okay, that's it. Now let's move on to 9.2. Okay, so moving on to 9.2, let's change the color. Let's go red for 9.2. Just make sure pick the thickest one. So we've got, let's say, determine the derivative of y in terms of x. Okay, so I'm just gonna say y is equals to 4x to the power 5 minus 6x to the power 4 plus 3x, and then differentiation of y in terms of x is, therefore, if I bring this down here, it multiplies a 4 and a 5, that's 20. X, 5 minus 1 is 4. I bring 4 times 6, that's like 24, I guess. I think so. So it's gonna be minus 24 x, and then 4 minus 1 is 3, plus, okay, this one's just gonna be 3. That's it. That's all we gotta do. That's the final answer right there. Okay, let's move on. Let's change our color to blue, and then we're going for 9.2.2 because this was 0.1. Okay, so now they want us to differentiate in terms of x, and what we have is that they've given us that square root sign is an x, there's a 2 plus a 1 over 3x squared. So what we have to do here is convert everything into one line. So I'm going to take out this number here, and it's gonna be the differentiation of this. Let me just put the brackets like they did, and then to solve it then I'm gonna take out the half, okay, so that I'm left with the square root of this. Oh, and it's negative. Okay, and then the square root of that, it's like saying x to the power 1 over 3. Okay, let me just rewrite that nicely. 1 over 3. And then that's plus, okay, I'm gonna take out the 1 over 3 once again, separating the number from the variable. Okay, and then I'm gonna square both just to get rid of the brackets. So 1 squared is still 1. I'll square that 3. And then here I'm gonna have, if I'm gonna write the x into one line, it's gonna be x to the power minus 2, because that's how you bring this up there. And then finally I'm gonna have a half times a third, and that gives me minus 1 over, in terms of numbers, 1 over 6 x, and then this is 1. I need to subtract a 1, so I'm just gonna say 3 over 3, so that I can say 1 minus 3 is minus 2 over 3, same base. Okay, and then this one multiplying this here, I'm gonna have minus 2 over 3 squared is 9, and then x minus 2 minus 1 is minus 3. Okay, so that's the final answer. Well, I hope you understood everything that we just did on this question, but in the event that you didn't, do contact me on my email address www.mvtutors.co.za. book a free consultation, or you can WhatsApp me on 076-312-1107. I'll be glad to be your tutor. But before you do contact me, please speak to your guardian or your parent to make sure that you involve them. Tell them you need a tutor, show them these videos, show them the website, just to be able to convince them of our credibility. Well, that's it from me. I do hope that you enjoyed. Goodbye. Well, good day to you. My name is Filarasa Manana, and I will be your tutor right now. So, welcome to MV Tutors, and we are still doing the mathematics paper 1, the November 2021. You just wrote this a few weeks ago, so this is the memo that we are taking out. So we're in question number 10 now. So it says the graph of h of x is given by that ax cubed plus bx squared is drawn. The graph has a turning point at the origin and the point 4 and 32. A is an x-intercept, so there's A over there. Question 10.1, show that A is equals to minus 1 and B is equals to 6. Okay, they're talking about that A and B, so we have to solve it. Okay, let's go for black, and we are doing 10.1. So we are given h of x as ax cubed plus bx squared. Now we're told that this is the turning point, and we know theoretically to get the turning point you take the first derivative. Okay, this is the equation of a gradient. So this is gonna be 3ax to to the power 2 plus 2bx. Now the gradient at the turning point is 0, so we know that, so we'll substitute 0 there. And then we know that the turning point is at a x value of 4, so we're just simply going to substitute. Okay, so let's make that a. We're simply going to substitute 4 there, plus 2b times a 4. It's still going to be 0. What's 3 times 4a? Wow, I need a calculator for that. So it's 3 times 4 squared. That's 48. So we got 48a here, plus 2 times 4, that's 8b. Now I know I'm gonna do simultaneous equations, so I'm just gonna go ahead, make b the subject of the formula, and it's just simply gonna be 48a divided by 8. So b then is gonna be equals to, remember when I take the 48 to the other side, it becomes negative, so then that's just gonna be, it's 48 divided by 8. Let's put that in a calculator. That's gonna be 6. Okay, so we've got minus 6a. Okay, so that's b. That's gonna be my equation number 1. Cool. No. Where did I get this negative from? Anyway, just wanted to move this up. Cool. So now what we're going to do is that we need to figure out another clue that we can do. So this is a point that passes the graph. So we know exactly that this point is passing the graph. So we can take h of 4, which we know is going to be 32, but let's just substitute first. It's the original equation, so it's going to be 4 cubed plus b and 4 squared. Alright, let's bring back our calculator. Okay, so we know this is going to be 32 because we've been given 4 and 32 is equals to 4 cubed, so it's 4 to the power 3, that's 64. A plus 4 squared is 16b. Cool. Now this is gonna be equation number 2, right? And then we're gonna take equation number 1 and we'll put it into equation number 2. Okay, and how's that gonna look like? It's gonna look like this. 32 is equals to 64a plus 16b is given by minus 6a. Okay, so let's bring our calculator again. So now we're gonna have this side, it's still gonna be 32 is equals to, if we just say 64 minus because of this negative, minus 16 times 6, it gives us a minus 32a. Okay, and then we can continue further then and say to get rid of this, we divide both sides by negative 32, which means my a is just negative 1. If a is negative 1, if we take equation number 2, remember equation number 1 says b is equals to minus 6a, so a is minus 1, so really b then is a positive 6. So those are my two answers right there. Okay, that was a very long question, but we got to the answer right there. Okay, let's move on to 10.2. Okay, 10.2. Let's go red this time. So we got 10.2. Calculate the coordinates of A. Okay, let's remind ourselves what's A again. A is the x-intercept. And then how do we calculate x-intercepts? We always say let y equal 0, and then we solve for x. So what do we know so far? We know that h of x is equals to a is minus 1, right? So it's minus x cubed and plus, and we know b is equals to 6, so it's 6x squared. Now we're gonna say let y equals 0, and then we'll have 0 here is equals to, now I need to factorize this. I'll take out x squared because x squared is common number. It's the highest common factor amongst both of them. So to get that, I have minus x, and here I have plus 6. Okay, so this gives me two answers then. I have x is equals to 0, and I also have minus x plus 6 is equals to 0. So let's just solve for x here. Therefore x is equals to positive 6. So what do they want? The coordinate. So the coordinate then for A is 6 and 0, just like that. Cool. Then let's go to the next question. Write down the values of x for which h is increasing. Okay, let's go for blue this time. So this is now 10.3.1 for which x is increasing. So you're always coming from the left going to the right. So coming from the left, we hit the graph there, and then we go down, we decrease, but as soon as we hit 0, we're increasing until we reach that point of 4 there, then we start decreasing again. So we're really just increasing from 0 to 4. So we're gonna say x is an element of it starts increasing from 0 to 4. Okay, and it's curved graphs because brackets, because these numbers are not included since it's flat over there. Okay, and then the next one is 10.3.2, where it is concave down. Okay, concave up is a smiley face, concave down is a sad face. So but where does it start to be concave down? Really, it starts at the point of inflection, and that point of inflection is actually 2, because it's between 0 and 4. So the number between 0 and 4 is 2. So we're going to say x is an element of, it's concave down from 2 to infinity. That's it. And then the next question is, for which values of k will this have one negative and two distinct positive roots. Okay, let's see what's going on here. So for this one, this is 10.4. Yeah, it's 10.4. So let me just rewrite this formula so that we can see. Okay, first of all, let me write what h of x is. H of x we know is minus x cubed plus 6x squared. Right, now this one that they have given us is actually minus x minus 1 cubed plus 6 x minus 1 squared minus k. Okay, so what we have here then is that it's such that we can see this is a horizontal shift to the right, this x minus 1, and then k is a shift on the vertical. So just to put it into perspective, what we initially have is that we have a graph that's like this. It comes here, it turns, and then it does that. Okay, and we know that that value there is 32 on the y. This is 0. Okay, so currently it has, if you look here, it has no negative roots. It has one positive root over there, the x-intercept, and then I don't know, this turning point, maybe let's include it, but it's 0 is neither positive nor negative, so it really has just one positive root. But here they say they want it to have one negative and two distinct positive. Okay, anyway, first of all, let's shift this graph. So what happens if we shift this graph? This point comes here, 1. That one is still at 32. This one then comes here, and then we have a y-intercept. So it's gonna be like this. My drawing skills are bad, but let me just try again. It should be something like this. Turns there, it turns there. Much better. Okay, so now we have a value there, y-intercept, okay, with this shift. Okay, so let's solve this y-intercept. We say to solve a y-intercept, we say let x equals 0. So really we'll have minus, let me just say then, write the statement, let x equals 0, so that it's clear that we are solving a y-intercept. So we're going to have minus 0 minus 1 cubed plus 6, not a x there, plus 6, 0 minus 1 squared. So this is going to be minus 1 cubed is minus, so this is going to be a positive 1, plus 6, because that's going to be positive 1 as well. So our answer is 7. Okay, so our y value then is 7, our y-intercept. So we know it's 7 there. Now for this graph to have two one negative and 2 positive, it literally has to move down by at least 7 units down. Okay, so what does that look like? It looks like this. That graph then would look like this. For it to, so it's this blue one. It needs, if we shift it down, that's gonna be more than 7. It's gonna do this, and it's gonna come here. It's gonna turn there and be like that. So now look, it has 2 roots there that are positive, and 1 root that's negative. That's exactly what they want. But if you move this graph too much, more than 32, what will end up happening is that this graph eventually will lose the turning points there. It will look like this if we move it too much. It's just gonna have one negative and no positive roots, so you can't shift it down too much. So then therefore we can say that k, since k is a shift down, it's negative there, so we'll put a positive value. K should be between, let me write it like this. Oh my goodness, I've forgotten to write k. K should be bigger than 7, but must be less than 32. Just have to think of it logically like that. Alright, that's it. Now, if there's something you didn't understand in these explanations, please do contact me. I'm available to tutor you at any time. You can go to my website, www.mvtutors.co.za, book a free consultation there. Or alternatively, you can WhatsApp me on 076 312 1107. Now, before you contact me, please involve your guardian or your parent. Let them know that you need a tutor. Show them our website, show them our video, whatever resource that's gonna prove that we are credible and we are available to tutor you. Remember, they have to be involved in this process because they are the ones who will be paying for our services. Other than that, it's goodbye from me, and I hope you understood. Enjoy.
Well, hello everyone, and welcome back to MV Tutors. I'm Solo, and I'll be looking at question 11 with you guys. So yeah, without wasting any time, let us get to it. Please don't forget to like our videos, subscribe to our channel, and spread the word. For those who are done with their final exams, please guys give or hand over the information, the links to the grade 11s who are going to need it next year. Okay, so what does question 11 say? Alright, so after traveling a distance of 20 kilometers from home, a person suddenly remembered that he did not close a tap in his garden. He decides to turn around immediately and return home to close the tap. So the cost of water at that rate, or at the rate at which water is flowing out of the tap, is 160 per hour. Okay, and the cost of petrol is that rands per kilometer, where X is the average speed in kilometers per hour. So what they want from us is to calculate the average speed at which the person must travel home to keep his cost as low as possible. Okay, so the average speed being X, so we must calculate the value of X, okay, so that his cost will be a minimum. All right, and if I hear minimum, maximum, I know that differentiation is involved. Okay, we're going to have to get the first derivative, make it equal to 0, and then solve for X. But now, what is that equation for X? Okay, so this person traveled 20K, all right? He went 20K and then realized, oh snap, I did not switch the tap over, I did not close it. Some would say I forgot to switch off the stove, and then he had to go back. Okay, so you had to go back another 20 kilometers. So this question was a bit tricky in that, what do you choose? Yes, they asked calculate the average speed at which the person must travel home. Are you going to consider the entire trip? Okay, where it would be 40 kilometers, or are you just going to consider the halfway trip where he just went back home? My thing is, this water has been dripping from the time he left home until the time he went back home. Okay, so the cost of water has been going, okay, from the time he left home and the time that he returned. Okay, and then also the petrol has been used up from the time he left home until the time he returned. So if they only want half the distance, I don't know, is that the full reflection of the cost? If they say calculate the average speed at which the person must travel home to keep his cost as low as possible, are we just considering halfway, or are we considering the whole trip? I would consider the whole trip because it's costing him, okay? But if you would rather do it halfway, yeah, you're more than welcome. So I will actually do both, okay? I will consider the whole trip, okay? And I'm going to also consider going back home, okay? Travel back home. Just the scenario of travel back home, and we'll see. What would I do in an exam situation? Because you can't give two answers. You only have to give one. I would do both simultaneously and at the end see which one do I like, which one actually speaks to me, and then I would stick with that one. Okay. So anyway, let us get the cost of both. We have the cost of, what are we starting with? Of that water. Okay. So I'm just going to say the cost of water. And I also want to get the cost of petrol. Okay, and let us see. So it was 1 rand 60 per hour. Ne? Somewhere there I need to slot in X. Okay, and I know that X is kilometers per hour. Okay, so I'm gonna put the hours here and then the kilometers. So X kilometers, because I just want these hours to cancel out. And then I'm going to consider the distance that he traveled. So since I'm considering the whole trip here, it is going to be 40 Ks. On the other side, the cost, just going to say C, water. I also have 160 per hour. Okay. And I have that speed which is traveling in, which is X kilometers per hour. And I'm going to multiply by the distance, which is him just going back home, which is half the distance. That's 20 kilometers. All right, and then the cost of petrol. Well, what do we have here? We have 1,2 plus, not times, plus. Okay, let's just go back. So we have 1,2 plus X over 4,000. Okay, and it is rands per kilometer. Okay, and to get rid of the kilometer, I'm just going to multiply by 40. And then here, same thing, rands. So I have 1,2 plus X over 4,000. All of that divided by kilometers. And we're going to multiply by 20. Okay, so now we're going to get our cost. Okay, we're going to get our cost in terms of X. Okay, so maybe let us do this. Cost in terms of X. Okay, So if I do the first one, the hours are going to cancel, the kilometers are going to cancel. So I have 40 times 160. What is 40 times 160? Okay, calculator. So 40 times 1,6, that is just 64. So I have 64 over x. Okay, yeah, and then I'm gonna have to add the cost of petrol. So if I take 40 times, oh, let me just, while I'm there, well, 20 times 1,6, that's just gonna be half of 64. So I'm gonna get 32 here over x. Now if I say 40 times 1,2, no man, 40 times 1,2, that's basically 48. So I have 48, and then plus, so 40 over 4,000 divided by 4,000, that is just 1 over 100. So it's just going to be x over 100, right? And yeah, that's pretty much the cost of petrol. So this side, I have 20 times 1,2, half of 48, that is 24. All right, and then I'm gonna have 20 over, I think that's gonna be 1 over 200. Okay, I need to sneeze. Sorry about that. Okay, so that is going to be x over 200. Okay, let's see where this takes us. All right, let me rewrite it like this. I have 64, x to the power negative 1, plus 48, plus 1 over 100, x. Okay. Here, again, cost in terms of x. Okay. I have 32 times x to the power minus 1. It's just better getting rid of fractions, especially when you're going to differentiate. It just makes life so much easy. Okay, so now we're going to have to differentiate, right? And then make it equal to 0 because we want the minimum. Okay, so when I differentiate, I'm going to have to bring the negative 1 to this side and subtract 1. Okay, constants fall out, so that's going to be plus 0. We're not putting it in. And here I have a 1 here. I'm going to multiply by the constant, and I have x 1 minus 1, which is x to the power 0, which is 1. So I'm not going to write that down. Okay, and then if I do it this side, same story, negative 32 x to the power minus 2. The constant falls out, and I have 1 over 200, and that's equal to 0. Now we can solve for x. Okay, guys, we are like almost there. Okay, so what I would do, let's just see which is a better way to do it. So I'm gonna say 64 over x squared, okay, is equal to 1 over 100. Okay, it's like me taking the negative 64 x to the power minus 2 to the other side. Okay, but I just want 64 over x squared on the left side. Okay, or actually let me just put it on the right hand side because I'm gonna take it back. You'll see what I mean when I say I'm gonna take it back. So here I have 1 over 200 and then equal to 32, and maybe let me just say 32 over x squared. Okay, so now I'm going to cross multiply. Take the x squared to the one side, take 100 to the other side. So I have x squared, and then 64 times 100, that'll be 6,400. And do the same here, x squared. Okay, 200 times 32, it's probably just half of that 6,400, but let's see. 200 times 32, oh, it'll be equal to the same. Okay, so whether you took the whole trip or whether you took half the trip, it's actually going to give you the same answer, guys. Okay, so it's really up to you. What is your understanding of the question? Okay, so you know how you're gonna get a plus minus something, but here's the thing, you can't have a negative speed. Okay, so we're definitely gonna take the positive. Okay, so whatever answer we get, it will definitely just be the positive. So 6,400 square rooted, that's just going to be 80 kilometers an hour. Okay, same here, 80 kilometers per hour. So yeah, guys, so that is the average speed at which he must travel home to keep his costs as low as possible. Okay, so I hope you understood that. My nose is runny, I need to blow it. So I'm gonna say goodbye for now until I see you for question 12. All right, don't forget to like our videos and subscribe to our channel. Hello everyone, and welcome to MV Tutors. I'm Tsolo, and I'll be looking at question 12 with you guys. We are there at the end. Thank you for sticking with us through it all. And yeah, guys, please do not forget to like our videos, subscribe to our channel as well, and also spread the word, especially to the grade 11s that will be in matric next year. And for those of you, you guys are done pretty much. For those of you who really felt like this paper was tough and maybe you would like to do a rewrite next year, upgrade, especially if you want to do like medicine or engineering and you know that your marks are not meeting the minimum requirements, this will be the go-to paper for you. This will be the time in December just to reflect, look at what you did, correct yourself. Okay, don't be so hard on yourself. And please, for those of you who feel like your friends are going further whereas you are just stagnant, guys, you're on your own journey. Okay, your own journey, your own challenges, and you know you can definitely overcome. So don't feel like time is just running out. You do have some time, so take the time now to just go over this, see where you went wrong, see where you can, you know, better yourself or improve. And yeah, and I hope all the best for you guys. Okay, so let's just do question 12 and see what the probability section has for us. All right, so they tell us A and B are independent events. Okay, it is further given that the probability of A and B is equal to 0.3 and probability of only B is 0.2. So as soon as I hear independent events, okay, independent events, I'm thinking that the probability of A and B, or you could say probability of A and B, okay, that is equal to the probability of A times the probability of B. Okay, and that basically is the intersection. So they tell us that that is actually 0.3. So if I were to put it in a Venn diagram, so I would have A there, okay, and because there's an intersection, I have B there. Okay, so let me just try that again. It's not recognizing my circle. There it is. Okay, and then I have gosh, what did I do now? All right, let's just zoom in again. All right, so okay, let's try again. Okay, and all of that, putting it in a box. Right, great. So we have event A, we have event B, and maybe there are some that are not involved. We're not sure, but we know that our sample space at the end of it all should be 1 because we're dealing with with probabilities. They haven't given us values. Okay, so we know that the intersection there, that is going to be 0.3, and only B will be 0.2. So at the moment, we don't know what only A is. Okay, we don't know as well the events that are not or rather activities that are not involved in these two events. But we know that our sample space, when we add everything up, it must be equal to 1. The probabilities added all up must be equal to 1. If you get something bigger than 1 or smaller than 1, when you add everything up, something is wrong. Okay, so with that being said, let us go and answer the questions. So now it says, are A and B mutually exclusive? Okay, so for mutually exclusive events, you would have a Venn diagram where you would have A there and you would have B there, and there wouldn't be any form of intersection. Okay, the events would literally just happen without coinciding at any point. Okay, so no, they are not mutually exclusive. And they say motivate your answer. I would say the events coincide. Okay, if you want to be more technical, you could say A and B is equal to 3. There is an intersection. Okay, they happen at some point at the same time, so the events coincide, hence they are not mutually exclusive. All right, and then now 12.1.2, they say determine the probability of only A. Okay, so basically if we look at our diagram, it's the part where we have X. What is only A? Okay, so only A, if I were to take, according to my independent formula, if I were to take probability of A times the probability of B, we know that it's going to be equal to 0.3. Okay, so what is the probability of A? Probability of A, that is just me looking at the whole circle concerning A. Okay, not just do that. So basically, it's all of A. Okay, so all of A is X plus 0.3. Okay, and then if I were to look at the probability of B, that's basically all of B. Okay, and that'll be 0.2 plus 0.3, and all of that, when it intersects, it's 0.3. So now we're just left with solving for X, which is indicative of probability of only A. Okay, so we have X plus 0.3, and then here we have 0.5 as 0.3. So X plus 0.3 is equal to 0.3 over 0.5. So that's basically 0.3 divided by a half. If you are dividing by a half, it's the same as multiplying by 2. So here I'm going to get 0.6. And if I want X alone, I'm going to have to subtract by 0.3. So the probability of A only, maybe let me shift it to the side. Probability of only A, that's going to be 0.3. Okay, so I can then go and update my Venn diagram. Okay, what did I do now? Okay, so if I update my Venn diagram, I know that that is 0.3 and that is 0.3. Okay, so A and B happening, I already have 0.3 plus 0.3, or rather A or B is 0.3 plus 0.3 plus 0.2, which is 0.8. So whatever that is not involved in those two events, that's going to be 0.2. Okay, now moving forward, we're gonna do B now. Okay, now they say probability of not A or not B. Okay, I know these things can get somewhat confusing. Like, yeah, so I just wanted to go through a little bit of theory. If you guys want to move on and just get to the answer, you can fast forward. But those who just want to get a little bit of theory, we can then look at some scenarios so that when you answer this question, it's actually easy for you. Okay, so yeah, I just wrote my notes here, so I'll be referring to them so that I don't forget anything. Okay, if you had a scenario, we've already discussed this one. So if we were to say, I want the probability of A and B, that's pretty much the intersection. Okay, that's pretty much the intersection there. All right, but if I said the probability of A or B, so the union is pretty much just saying or. Okay, so the probability of A or B, again, if I were to have A and I would have B, this is now for non-mutually exclusive events. And I have my sample space over there. Okay, or would mean, so I have A, so that's the all of A and all of B. Okay, so this is the or scenario. So here we have the intersection and here we have the union, and that's why you would get let me put it as O. That's why you would get this equation where it says you have the probability of A plus the probability of B minus the intersection. Okay, A and B. Okay, so now another scenario. What if they said the probability of not A? Okay, not A, that's the same as just saying probability. We indicated with that semicolon there. Okay, is it a semicolon? No, apostrophe, sorry. Apostrophe. Okay, so if I were to have just event A alone, okay, and I have my sample space. Ooh, let's see how it'll come out. No. Okay, so if I have my sample space over there, okay, not A means everything outside of A because it's not A. Okay, and another scenario, if I said probability of A or not B. Okay, so basically another way to write it, probability of A or not B. Did I write it correctly? Okay, so here it gets a little bit tricky. Okay, so if I have A, let me do it in steps. So let's just look at the probability of A alone. A with B, right? So I have A there, I have B. So if I were to look at A, this is what I would shade in. Okay, if I were to look at not B, okay, with my sample space over there. Okay, so not B would mean everything around B. Okay, including that. Okay, so not here though. Okay, now when we put it together, remember if we say or, it's basically we're including everything. Okay, so we have probability of A and not B. So basically, if you see here what we have indicated, so it didn't make a circle for me. Okay, it doesn't want to form that nice circle. Wow. Okay, let me just leave it, it's fine. Oh, now it does it. So if we have A, remember for A, if you look here, we shaded everything. And when it's O, you're basically including everything, right? So we shaded everything for A. Okay, and then for B, we shaded everything except B. Okay, so if you're going to look at the probability finally of A and not B, you're basically going to have shaded. Okay, so B, this side is not included. Okay, but because A was included previously, we're going to have to include all of it. So basically the only part that is not shaded here, it's the B only. Okay, so if you have, maybe let's say in summary, if you have this type of equation where it says probability of A or not B, it's everything else. It's basically your sample space minus the probability of only B. Okay, because your answer is going to be everything that's shaded. That is your answer. Okay, so if you want to like calculate it easily for yourself, especially if you have only B, you can just say the whole sample space minus only B will give you the probability of A and not B. Okay, so now what if you have a scenario where it is probability of A, or rather not A and not B? Okay, so if you have not A, let me just try to do it in one Venn diagram. Okay, sorry for taking up time, but I think it's important that we do this little bit of a summary. Okay, so if it's not A, remember this is A, that's B. If it's not A, it's everything around A. Okay, I think let me just do this in stages. So this is probability of not A. If I'm going to look at the probability of not B, same thing. Okay, so we have A, we have B. So not B, again, is everything around B. That is not B. But now we are saying, what is the probability then of not A and not B? Well, if it's and, we're looking at the intersection of the events. Okay, we're looking at the intersection. So where are they happening at the same time? Okay, so we have A over here and we have B over here. So and you can see all around A and B, we have that scenario here, we have that scenario there. So that's where they intersect. Okay, so we can put it all around. Okay, but now we have a shaded area for B here and we don't have a shaded area here, so they don't intersect, so we're not going to shade anything inside B. Here with their intersection, right, we don't have any intersection here, nor do we have anything here, so we're going to leave that open. And when you look at A, you only have A this side, but it's not shaded that side. So basically we're not going to cover A as well. So that is a scenario where you have the probability of not A and the probability of not B. Okay, so now probability of not A and the probability of not B. So what happens, which is our question now, when you have the probability of A, not A, or not B? Not A or not B. Here we had and, but now we're looking at or. Okay, so with that as well, what I would say, sorry, my nose is a little bit runny. Okay, so probability of A or not B. What I would look at, just to simplify my life, I would look at the probability of A or B. Okay, the probability of A or B. Okay, I want the perfect square. Doesn't want to form. You know, it happens, then sometimes it just doesn't happen. Okay, maybe let me just finish off. It's fine. Yeah, it's fine. So probability of A or the probability of B, that's basically the shaded part. Okay, but if we were going to look at the probability of A or probability of not A or the probability of not B, that's just pretty much the opposite of that. Okay, so we're going to shade everything around. If both of them are not included, we're not including A, nor are we including B. Okay, so it's going to be everything around. So what I wanted to demonstrate here, guys, if you look at these two, the probability of not A and the probability of not B, that is really the same as the probability of A, not A, or probability of not B. They are the same. Okay, you only shade the area around. Okay, you're not involving A, you're not involving B. Okay, so and or for the nots, they're the same. Okay, so when we look at now our question B, there's the probability of not A and the probability of not B. Okay, so remember our Venn diagram. Okay, this is A, this is B. Okay, just gonna zoom in there. All right, we had 0.3. Okay, now this thing is quite small. Let me just make them a bit bigger. Our intersection was 0.3. B only was 0.2, A only was 0.3, and everything else outside, that's just 0.2. If they say the probability of not A or not B, like I said, now that's pretty much the area outside. Okay, everything outside. All right, and everything outside is 0.2. Okay, another way of doing it, you would have said, what is the probability of A or B? Okay, that'll just be the probability of A plus the probability of B minus the intersection. Okay, and then we know probability of A, that's 0.6, probability of B, that's 0.5, minus the intersection, that's 0.3. So 0.6 plus 0.5, that is 1.1. 1.1 minus 0.3, that's 0.8. Okay, and if we want to get the probability of not A or not B, that's like taking the sample space and subtracting the probability of A, probability of A or probability of B. So our sample space, like we said, it's 1, and if you subtract A or B, that's 0.8, and then finally you would get 0.2, the probability of not A and probability of not B. Okay, sorry for taking so long, but I feel like sometimes it confuses people, and it was only 2 marks. Okay, but I hope the little bit of theory that we covered makes sense. All right, now we get to 12.2, the counting principle. Okay, what does it want from us? 12.2. So a teacher has 5 different poetry books, 4 different dramas, and 3 different novels. She must arrange these 12 books from left to right on a shelf. Okay, so we have 12 spaces. Okay, and because these are books, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They are different, right? You can't get repetition here. You can't say, if you're gonna, maybe let's say, get the, what is the probability, or in how many ways can she arrange it? Well, you can put, we have 12 options here, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So there are 12 factorial ways in which you can arrange this. Okay, you can't have a scenario of 12 to the power 12 because you can't repeat it. Once that book is used, it's used, and that's it. Okay, so just be aware. All right, and now let us go to 12.2.1. So write down the probability that a novel will be the first book placed on a shelf. So how many novels are there? There are 3 different novels. Okay, so we have so probability of a novel. We have 12 books in total. Novel is just 3 of them. Okay, so the probability that it'd be a novel, that'll be the first book placed on the shelf, it's 3 over 12, and 3 over 12, it's like a quarter. Okay, or you would say it's like, 0.25. Okay, so that is just the probability, and that's 1 mark. So it really wasn't that deep. Okay, and then we have the second part. So 12.2.2. Calculate the number of different ways these 12 books can be placed on the shelf. If any book can be placed in any position, okay, that will just be the 12 factorial, guys. Okay, we have number 12, number 11, 10, 9, 8, 7, 6, 5, 4, 3, 2. And you're multiplying this. So factorial just means you're multiplying, okay? Now, instead of us doing this all the time and wasting time, imagine putting this in your calculator. 1 times 2 times 3 until 12. That's going to take forever. So what we do use is the factorial. Okay, so we have 12. Shift factorial. And that would be 479 million. Okay. Yeah, and 1,600. Okay, so that is that. How many marks for that one? 2 marks. Okay, and then 12.2.3. Now it says calculate. Let me just take this page up. We're almost there, guys. We are there. 4 marks. Last question. Calculate the probability that a poetry book is placed in the first position. Let me put my, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Calculate the probability that a poetry book is placed in the first position. How many poetry books do we have? We have 5 poetry books. So in the first position, I have 5 options. Okay, remember there are 5 poetry books. So there are 5 options that I have there, and that is fixed, right? I'm putting the poetry book in the first position. 3 novels are placed next to each other. Okay, where are they placed next to each other? I don't know, anywhere along the shelf, but they must go together. Okay, so basically I have 3 positions. Why? Because novels are 3. We just calculated the probability to get a novel. So there are 3 of them. Okay, and here with those 3 ones, I can place them however way. Okay, so basically it's going to be like a 3 factorial in there, and they go together. Okay, so I can put the first book, if I have 3 novels there, they can change position, but they must be together. Okay, they must be together. So that's why I say 1 times 2 times 3. The 3 novels must be together, but how exactly are those novels arranged? They can be arranged anyway. Okay, that's why we put a 3 factorial. Okay, so are the novels next to the poetry book? They can be. Or I can put the novels there. or I can put the novels there. The novels can be placed anywhere, guys. They're not fixed. Okay, they're not fixed. And then lastly, they tell us a drama is placed at the last position. So there it is fixed. Okay, they're telling us a drama placed at the last position. It's a fixed position. Okay, and how many dramas do we have? We have 4. So there are 4 options we have there. Okay, guys. So the first position and the last position, they are fixed. There's nothing we can do about it. So the number of options that we have 5 times whatever. And then times 4. So what happened in the middle? We have 5 times. Remember the 3 novels that go together? So we're going to have that 3 factorial. And then what about the rest of the books? We have 1 option there. The second option. Okay, so let me just do this. I'm going to start this side. So we have how many options left? We have 1, 2, 3, 4, 5, 6, 7, and 8. The novels, they go together. They always go together. So whether you put them here or whether you take them there to the end, or whether you put them here or whether you put them here, listen, they must go together always, regardless. Okay, so it's like 1 unit. All right, and that is why we put 8 there. So 2 fixed positions, we have them, but the other 8 can move however way they want. And because they can move however way they want, we must put an 8 factorial there. Okay, I really hope that makes sense. Okay, yeah, if it really doesn't make sense, please look at your textbooks. Look at these kinds of examples where you have fixed positions and you have freelancers, if I could say. They go together, but wherever they are, they must be together, but they can move around. Okay, so that's pretty much what we're going to calculate. So the number of ways those can be arranged, let's check on the calculator. So we have 5 times 3 factorial times 8 factorial times 4. Okay, and we have an answer of, what is it? It's 4,838,400. But they didn't ask us for the number of ways this can be arranged. They asked us to calculate the probability that you can place the books in such a manner. So we're not done. Okay, so we need to calculate the probability. Okay, so the probability that, yeah, the books can be placed in such position. Basically, we have what we have there, 838,400 all over 12 factorial. Okay, and then our answer will be 12 factorial, and our answer is, what was it, 1 over 99, which is 0.01. At some point, I thought they removed the counting principle from this year's syllabus, but it's still there. It's actually a nice, I really think it's nice. It's quite exciting, but it can be confusing, especially with these kinds of things. We now, these books are fixed together, but they are flexible while fixed. It's like, what? So yeah, more practice is required. The more practice you do for the counting principle, the better it becomes. Okay, so yeah, thank you guys for tuning in. We are done. Like I said, please don't forget to spread the word, especially to the matrics the grade 11s who will be in matric next year, and for you guys who are considering upgrading because you saw that this paper showed you flames. And yeah, that's it from me. See you paper 2.